Hello. Hello. Very good evening. Very good evening. Welcome, Vanakkam, Suswagatam. Namaskaram. जो बोले सोनियाल सस्त्रीकाल वालेकुम सलाम अस्सलाम वालेकुम. Welcome, Vanakkam, Suswagatam. Very good evening. This is your Baba HSP. Everyone, just do let me know. Can you hear me? Can you see me? I'm here. Am I perfectly audible and visible to each and every one of you? Kids, just to let me know. If yes, if your answer is yes, I want to see green hearts in the chat section. If you can definitely, yes, my dear friends, if you are with full on Josh, I want to see green hearts in the chat section, kids. Really fantastic, really fantastic. What I can see that everyone, yes, but kids, so less attendance. You have to mark your attendance by, yes, smashing the like button. Everyone, your one like will increase my energy level. My dear students, only those students who are with full on Josh, today we are going to deal with alkenes and alkynes, carbon double bond carbon, carbon triple bond carbon, unsaturated compounds. My dear students, unsaturation, double bond in between two carbons known as olefins. What do you call it? Olefins. If you see C double bond O anywhere, it's not unsaturated. C triple bond N, not unsaturated. C triple bond C, acetylenic bond. Today I will tell you each and everything about alkene, alkyne, their preparation, their chemical properties. But kids, how is the Josh? Do let me know in the chat section. If your Josh is high, I want to see some fire in the chat section so that I can start today's session. Because this alkene and alkyne holds a hell lot of weightage. Everyone, my dear students, what I want to see that everyone is there, and if you are with full on Josh, show me some hearts along with fire so that I can start. I'm your Baba HSP. Today the introductory slide is not there because I think that you are aware of Baba HSP, the chemistry faculty. And today I will tell you first what I am going to start. Let me tell you first of all the flow of today's class. First I will tell you, kids, preparation of alkene. Preparation of alkene. Then I will tell you the chemical properties of alkene, each and everything about the chemical properties of alkene. After that, I will tell you preparation of alkyne, kids. Preparation of alkyne. And then I will tell you each and everything, means the chemical properties of alkyne. Chemical properties of alkyne, kids. Now, during this reaction, E1, E2, ESR, number of things, Markovnikov, anti-Markovnikov rule, each and everything I will go according to NCERT. And whatever is missing in NCERT, I will let you know even that thing, because 50% NCERT, the thing NCERT is going to write, NCERT writes in between the lines. I will elaborate those lines, kids, because they are also very, very important. Means each and everything you will see that is coming from NCERT, but whatever NCERT is writing in between the lines, those things holds a hell lot of weightage. I will tell you all those things. But my dear students, you have to keep patience. You have to keep patience for that, because if you want to understand the mechanism, you know, organic chemistry, each and everything is correlated. If you want to understand the mechanism, you have to, yes, put your efforts over there. Are you ready for that? Everyone, are you ready for that? What I want to say, everyone is ready? If yes, show me some fire so that I can start. And before that, let me tell you, kids, this is your Team Avengers, you know, Phoenix Masters NEET 2025 batch by Team Avengers, 600 plus lectures, 20 plus tests in English now at just rupees 5499. You have to apply code. What is the code, kids? Code is HSP10. HSP10 to get mentorship along with huge discount. After discount, this is available. You know that when you go and join offline coaching or any online or offline coaching, they are charging huge amount of money. But this batch, Phoenix Masters batch, is just available for how much? 5499, just for 5499, my dear students, right? Now, you know, Team Avengers, your Ambika ma'am, the best teacher of bio, Wasim sir, you know, Thalaiba, Yava sir, best physics teacher, and HSP sir, chemistry teacher, right, kids? My dear students, it is available just for this Nimbus batch. Nimbus batch is for class 11th. I would like to say it is for class 11th. Class 11th, you call it Nurture batch, Nimbus batch. It is also available for just for rupees 5499, and apply code HSP10, kids, HSP10 to get mentorship and huge discount. Now, my dear students, Sachin, Neha, you know, UNSAT. This is Unacademy's National Scholarship and Aptitude Test, ITJ, NEET UG class 6 to 12. Your junior, classmates, relatives, anyone. Sharing is caring, and Almighty God is going to help you if you are sharing it to everyone. Right? Register now. September 22, October 20. Duration is 60 minutes. Now, kids, let me start. So, Baba is going to start chemistry and this properties. Let me go with. Are you ready, kids? Everyone ready? Let me see the chat section that what kids are writing. Kids, everyone, are you ready? Let me see. Yeah, this batch is equally good. This batch is equally good for IIT as well as NEET students. Whatever the content I am going to give you, that is equally good for both type of students, kids. Both type of students. Both type of students can go with this. Now, I am going to start. Okay? Now, preparation of alkene. Alkene preparation, kids. Alkene preparation. This alkene preparation, I would like to say that alkene preparation is common in 11th plus 12th. I would like to say in 11th, it is given in hydrocarbon. Hydrocarbon. And the first alkene preparation, this is given in class 12th, first chapter, class 12th, part 2. Now see, what is the preparation of hydrocarbon alkene is the same chemical property of alkyl halide. Alkyl halide chapter, RX, haloalkane, haloalkanes, haloarenes. Say yes or no, kids. Its chemical property, its preparation. So if you are going to cover one thing at one place, that you are going to get benefited at two places, kids. The one preparation of alkene is the chemical property of alkyl halide. That means two chapters you are covering at single place. Kids, are you ready? Is everyone ready? Are you able to understand its chemical property and its preparation? Hydrocarbons preparation is the chemical property of haloalkanes. Are you getting my point, kids? So let me tell you that whole organic chemistry, if you are thinking that X chapters, if you do it, they are just XY2, because one chapter's preparation is the chemical property of another chapter. So in this way, if you are going to cover it up with the brain, that only half, that is 50% of organic chemistry, you need to go with that. If you are properly doing it, then 100% organic chemistry you are covering, kids. And remember that if you know at least 50% of your subject, then the options are going to help you a lot. More than 50% clarity, 100% you are going to take correct option. Less than 50% accuracy means your options will misguide you and you will get negative marks. Are you able to understand what I am telling you? So at least 50% of organic chemistry you are doing, 100% you are covering, and out of that 50%, if you are having good knowledge of at least 50%, means 25% only you need the proper knowledge of organic chemistry. 25% you will get 100% marks. It's a miracle. Are you able to understand what I am telling you, kids? Show me green hearts in the chat section if you are able to understand what I am telling you, kids. Let me see in the chat section that everyone is able to understand what I am telling you, kids. So the first preparation of alkene is from alkyl halides. From alkyl halides. Now if I talk about alkyl halide, then I will write Rx, where X can be equal to chlorine, bromine or iodine, but X can't be fluorine. And if it is fluorine, then also you will get alkene, but different way, different manner, different way you are going to get this. Wow, kids, everyone is able to understand. Let me see the chat, kids, because your communication is going to tell me. I don't want many students, but whatever the students, they are really thinking of their rank, I need only those much of students. Kids, everyone mark your attendance by showing the attendance as in the form of, yeah, very good, kids, very good. Now see, kids, let me tell you. First, the alpha elimination. And second is the beta elimination. Beta elimination. Beta elimination. Now, what is the difference between alpha elimination and beta elimination? Just see, kids. Alpha elimination means it is also known as 1-1 elimination. Beta elimination is known as 1-2 elimination. Now see, kids, if I write down, there is only one example of alpha elimination, that is chloroform, CHCl3. Now this carbon, the carbon on which halogen is attached, is known as 1 or alpha. Now KOH alcoholic will come. KOH alcoholic, remember that KOH alcoholic plus heat. Heat is going to favor elimination reaction. I will tell you how and why. It is not going to favor substitution reaction. It will favor elimination reaction. I will tell you the whole mechanism why it is going to favor elimination reaction. Now see, KOH will break to give K plus OH negative. Now this OH negative is base, and base is in need of proton, this will attack this proton, means it is not interested in the electron. It will take away this proton, will be taken by this OH negative, and H plus will eliminate out, and this will get negative charge. Carbon will get negative charge, chlorine, chlorine, chlorine. Now this negative charge is stabilized by back bonding. What is that back bonding? See, this chlorine is having lone pair in 2p, 3p, because fluorine, chlorine, bromine, iodine, 1, 2, 3, 4, 5. So it is in 3p. So its 3D is vacant. 3D is vacant, and the lone pair will go into this. So it will stabilized by 2p pi and 3d pi back bonding. That means it is acid, and this is the conjugate base. Conjugate base gets, it is the conjugate base. Now it is still having negative charge, so K plus, this K plus will come, and it will take away its chloride. It will take away its chloride. This chlorine will go along with electron. Now carbon has lost electron, so negative charge will get away. It will be like Cl, Cl. Now it is known as carbene. Why carbene, kids? 1, 2, 3, 4, 5, 6. Only 6 electrons. Only 6 electrons. Carbene is neutral electrophile. Don't get confused and don't say it is a nucleophile. If you are saying this lone pair, it's not the lone pair to be donated. It is electron deficient, known as carbene. Remember that. What carbene? It is carbene, neutral electrophile. Remember that. Neutral electrophile, kids. Neutral electrophile. Dichlorocarbene. Now this dichlorocarbene, will be responsible for 2 reactions. CCl2 dichlorocarbene will be responsible for 2 reactions in your future. Right now I am not going to discuss about those 2 reactions, but you should know. One is Reamer-Tiemann reaction. Second one is carbylamine reaction. Carbylamine reaction. Remember that. These we will discuss later on, but right now our target is alpha elimination. Why it is known as alpha elimination, kids? Because this carbon has lost chlorine, one chlorine as well as hydrogen, both has gone from first atom only. This is the only one reaction from one atom only. 2 atoms from the same carbon, 2 atoms have been lost, and carbon is electron deficient as well as valency deficient. I hope this point is clear to all of you. Now beta elimination. If I write carbon, halogen at this place and hydrogen at this place, just see, kids. Now the halogen is attached to this carbon. This carbon is known as alpha carbon or first carbon. Adjacent carbon is beta carbon or second carbon, right? Now KOH once again, alcoholic KOH will come, KOH negative. K positive will say, hey halogen, I am interested in you. So it will attack on this K plus and take away this halide as X negative, and this carbon will get positive charge. Are you getting my point? Now this OH negative will take this proton. This proton will be taken by OH negative, and you will get H positive will go along with OH negative, and this carbon will develop negative, and negative positive will develop double bond. Now see, kids, C double bond C, KX and water, because hydrogen has been lost by beta hydrogen, so it is beta elimination. Now my dear student, in detail we will study this beta elimination only. Till now is it clear, kids? Till now you're getting my point? Now this we will study in detail. Let me show you beta elimination. Now kids, again and again I am telling you who is going to favor this elimination. elimination. Elimination will be favored by temperature. Temperature favors, what gets temperature favors? Elimination reaction. Elimination reaction. Now, what's the reason why temperature favors elimination reaction? Let me tell you. Right now we have seen that this was the reactant. There was one halide and there was one hydrogen. Just see. One type of molecule and another type of molecule was KOH, alcoholic, and heat. Now you can see on the reactant side we are having two types of molecules, one alkyl halide, another one KOH alcoholic, and see the carbon which is attached to halogen is known as alpha carbon and adjacent carbon is known as beta carbon, or you can say first and second carbon. Now you have seen that this K positive has taken away X negative and this OH negative has taken away this. Right now I have shown you this. This is H, kids. This is H. This is hydrogen, and this OH negative has taken away this H positive, you can see, and negative. So how many types of products have been formed? See, negative and positive, they have formed the bond. We got alkene, plus we got water, plus we got KX. Two types of reactants got converted into three types. Now, if I apply thermodynamics, basics of thermodynamics, that three types of molecules have been formed from two types of molecules. So, delta S, final minus initial, 3 minus 2, that is coming positive. And if I talk about Gibbs-Helmholtz equation, Gibbs-Helmholtz equation, you know very well, Gibbs-Helmholtz equation, kids. That says delta G is equal to delta H minus T delta S. You know that two sigma bonds are breaking, one pi bond is getting formed, so energy required is more and released is less. Endothermic reaction, so endothermic means delta H is positive, that is also positive. So positive into negative, this magnitude will come negative, and if you increase the temperature, then that is going to dominate. If less temperature, then this delta H positive will dominate and the reaction will not give a good yield. But if this magnitude, temperature in Kelvin, it is always in Kelvin, if this temperature is more, this magnitude, negative magnitude will be more and delta G will come negative. That means this reaction is taking place at high temperature. So high temperature favors elimination reaction. This point is clear. If yes, show me green hearts. If no, show me fire. I want to see in the chat section, kids. Is it clear or not? Yes, fast, kids, fast. Everyone, quick. Quick, kids. Those who can't understand, Sausi, yeah, very good. Sagar Mitra, very good. Those who can't understand, remember that high temperature is favorable for elimination reaction. If you can't understand, remember one point. Only one point is required, kids. If you can't understand, then only remember one point. I would like to say just remember one point. What's that? What's that, kids? That high temperature is good for elimination reaction. You have to remember only one point, that high temperature is good for elimination reaction. If you can't understand, kids, remember that only one point. Remember only one point. What is that point, kids? That high temperature is good for elimination. High temperature is good for elimination. Kids, for understanding it, you should know thermodynamics, a little bit basics of thermodynamics. If you don't know that, remember one point, that high temperature is good for elimination, right kids? This you can keep in your brain. Now let me explain each and everything, kids. Are you ready? Is everyone ready, kids? So first preparation from alkyl halide. From alkyl halide. Now let me take example of NCERT. NCERT example only: CH3, CH2, CHX, CH3, where X can be either chlorine, bromine or iodine, but can't be, remember that, can't be fluorine, can't be fluorine, can't be fluorine, kids, can't be fluorine, remember that. Now kids, if I react it with KOH alcoholic, or NaNH2. NaNH2 is known as soda amide. Say everyone, soda amide. Soda amide. Now right now I'm dealing with E2 reaction, because whatever I'm teaching you kids, let me tell you that this beta elimination, if I say that beta elimination, this beta elimination is of two types. Before completing it, remember that beta elimination is of two types. Before coming to this reaction, let me tell you the base beta elimination is of two types. Remember that, two types. What are these two types? First is E2. Second one is E1. What these names are telling you: E2, E1. E2, E1. Before telling you that reaction, we should know the chemical kinetics. Do you have a little bit knowledge of chemical kinetics? If yes, show me green signal. If you are having little bit knowledge of chemical kinetics, if you know chemical kinetics, kids, show me green hearts. Otherwise, I have to tell you chemical kinetics approach. Then only I can come to that point. I can tell you this reaction only when we know a little bit of chemical kinetics. Otherwise, it's of no use. If you know about chemical kinetics, show me green hearts. This belongs to second order. It belongs to second order chemical kinetics. And this belongs to first order chemical kinetics. Kids, because cramming will not give you rank. If you're going to cram it, you are not going to get best rank, kids. You have to understand. Okay, these many kids don't know fire, they are showing fire. Okay, no problem, I will teach you. But tell me kids, those who are interested in the depth, they want to have the government seat. If your dream is to get the government seat, and if you want to understand with patience, no hurry, patience is required, then I will tell you each and everything in detail. And if you're running just like YouTubers, YouTube, I won't be able to tell you. If you are really interested in the rank, then you have to have a full faith on me. I will tell you each and everything in detail. Even I will tell you what's the chemical kinetics behind this. I will tell you each and everything in detail. Those who are interested in the rank, they have to go through these things in depth. In-depth knowledge is required. If you're ready, I will give you, show me green hearts or green leaps, whatever, or you write down. Let me see the chats. Let me see the chat, kids. How many of you are interested? See, Sahana is writing, kids, everyone. I need your green signal, then I will tell you each and everything. Otherwise, I will tell you in this way only just to complete your NCERT. You won't get rank then, kids. Wow, everyone, speed up, kids. If you want to get rank, really, everyone, kids. Okay. Very good. Now, I got that everyone is interested. See now. Second order and first order. Let me tell you the second order first. First, let me teach you the second order. See, kids. Second order chemical kinetics means that if I say there is a reactant, reactant is also known as substrate. There is a reagent. Here the reagent is also known as base. They will give you product. Now, second order reaction means that in the rate determining step, that rate of reaction is equal to K into the concentration. This sign indicates concentration of reactant power 1, reagent power 1. That means rate of reaction is directly proportional to the concentration of reactant as well as to the concentration of reagent. This is known as rate. It can be indicated with R. This is a rate constant. Its name is rate constant. Rate constant or velocity constant, or we can say specific rate of reaction, specific rate of reaction. This is the concentration. These brackets indicates concentration. You can say molarity, moles per liter. Its power is 1 and its power is 1. That means in the rate determining step, both are involved. Second order chemical kinetics means in the rate determining step. This indicates in the rate determining step, both are involved. In rate determining step, both the reactant and reagents are involved, and this can happen only when reaction takes place in single step. This is single step reaction. This has to be single step reaction, and single step reaction indicates no intermediate will get formed, no intermediate formation, kids. This indicates that no intermediate formation. And no intermediate formation means what, kids? No intermediate formation means no rearrangement can take place. No rearrangement, kids. No rearrangement can take place. No ring expansion can take place. Kids, you must have heard the name rearrangement, like hydride shift, methyl shift. They will not take place. They can't take place. remember that whenever we talk about E2 reaction, E2 reaction, it belongs to second order kinetics. Second order kinetic, and second order kinetic means that its reaction is elementary reaction. Elementary reaction means single step reaction, single step reaction, single step reaction, and single step reaction takes place without formation of any intermediate, no intermediate. Then what will form? Simultaneous breaking and making of bond. It will proceed through transition state formation. Transition state. I think these words you are able to understand, kids, what I am writing. You are able to understand these steps. Now, if I talk about these steps, that means it is a single step reaction. If I talk about E2 reaction, that is single step reaction. One more thing I would like to tell you, E2 reaction, about E2 reaction, kids. It follows anti-periplanar mechanism. E2 reaction follows anti-periplanar mechanism. Anti-periplanar mechanism. Now what is this? If very tough question is coming, they will ask this question, anti-periplanar mechanism. What do you mean by anti-periplanar mechanism? Kids, have you ever heard this name, anti-periplanar mechanism? Because whenever they are going to get this question, 99% people will get failed. See, what is this? Let me show you. Suppose if I say that this is cyclohexane, and it is attached with this chlorine. This sign indicates that something is coming towards your side, something is coming towards observer side, that this valency is coming towards observer side, this is coming towards your side, right? And if I draw over here methyl, this methyl is coming towards your side, kids. And if I write this hydrogen, this dash line, this is set to be dash line, this hydrogen is going away from you, this hydrogen is going away from you. Dash line means away from observer. And if I write here ethyl is going away from observer, and write here deuterium is coming towards your side, this is coming towards your side. Now see, with respect to this chlorine, this is alpha, this is beta, this is beta. Now who will eliminate? This protium, deuterium, you know, this is protium, this is deuterium, isotope of hydrogen. This is deuterium, isotope of hydrogen. Who will eliminate out? Then remember that who is anti to this anti-periplanar mechanism, anti and planar. Now this is coming towards observer, This is known as wedge line. Wedge means towards observer. Now this is towards observer, this is also towards, they are same side. There is one word for same side, syn. They are syn to each other. Syn means same side. Now this is coming towards your side and this is going away from you. So with each other, with respect to each other, they are anti. See, these two are anti to each other. This much is clear, kids. Anti to each other, because one is coming towards your side, one is going away from you, anti to each other. So who will eliminate out? These two eliminate out. This chloride will move This chloride will move by taking electron. This chloride will move by taking electron. It will take electrons. So here you will get positive charge. And this hydrogen will move by giving electron negative charge. So negative positive will form a bond. If you use KOH, alcoholic heat, then what product you are going to get? Your product should be like this, my dear students. It will be, double bond will be over here. This is methyl and this is ethyl, and deuterium will be there. Deuterium will be there. It's how many of you are able to understand? How many of you got it? Just do let me know in the comment section. Then I will show you one more example. Then I will show you one more example. First of all, do let me know in the chat section. Let me see, kids, how many of you got it? How many of you got it, kids? Kids, your signal, green signal, means a lot to me. That will help me a lot, kids. Now, if the same question they are asking, now kids, let me tell you one more thing before I move ahead. Remember one point. If I say carbon bonded to protium is like this. 3 isotopes of hydrogens. Carbon bonded with deuterium is like this. The second isotope, and the carbon bonded with tritium is like this. What you are able to understand from this? What you are able to understand? Let me draw it more appropriately. See, just to let me know what you are able to understand, kids. These are the 3 isotopes of hydrogen. One is protium, one is deuterium, one is tritium. This is being protium. This is being deuterium. And this is being tritium. Remember that, kids. More is the mass. More is the mass. More is mass. More will be electron donation. This is meson theory. This is the result of meson theory, kids. This is the result of meson theory. More is mass, more is electron donation. More will be the strength of bond. More will be bond strength. So from this knowledge, what do you think? This is the weakest bond. This is the weakest bond, kids. I would like to say this is the weakest bond. Means will break easily, and this is being the strongest bond. But kids, in your examination, generally you will get deuterium. Why? Because kids, in tritium, neutron by proton ratio is 2:1. In this case, neutron by proton ratio is 2:1. Maximum radioactive. It is being maximum radioactive. So it is not found in nature easily. Very, very less abundance. Very, very less abundance, kids. Now generally you will get deuterium. Out of these, this is weakest and this is stronger bond. Remember that. Now, how they will give question, kids? If you are really interested in quality content, then you have to remain over here. If you are interested in quality content, Baba is not going to give you low quality content, kids. Now see, everyone, why I am telling you all these things? Why I am telling you all these things? First of all, do let me know who is the strongest one. Out of protium and deuterium, this bond is stronger. Let me ask one question. If I draw like this, carbon to hydrogen and carbon to deuterium. Suppose I have given like this, which bond is stronger out of A and B? Which bond is stronger? So definitely answer is this is stronger bond. And this is your weaker bond. Am I right, kids? Which bond can be easily broken? This bond can be easily broken, and this is tough bond, stronger bond, right? Now see how they will give you, and they will play how they are going to give questions. See, kids, and maximum students, 99% of the students, definitely they are going to get failed in this question. See, they will give you question like this. This is the chlorine, this is the chlorine, this is deuterium, this is ethyl. Just see, they will not write anything. You have to understand yourself. Ethyl. Here is hydrogen, that is protium. Here is methyl. Now they have given, and they will write KOH, alcoholic, heat. What should be answer? What should be answer? Now who will eliminate out? This protium will go, or deuterium will go with this chlorine? Just do let me know. Just do let me know. I am waiting for your answer. This is alpha carbon, this is also beta, this is also beta. Do let me know in the chat section. This protium will eliminate out, or this deuterium will eliminate out. Who will eliminate out, H or D? Do let me know. Kids, you have to reply. You have to tell me the answer in the chat section. Otherwise there is no need of studying. Otherwise there is no benefit. You will not get benefited, kids, if you are not writing answer in the chat section. Do let me know, kids, what's your answer? Yes, kids, I'm waiting for your answer. H, everyone is writing H, kids. That's why I have told you, you will get failed. Now tell me, who is anti to this chlorine? This is coming towards observer side. This is coming towards observer, towards your side. Towards observer. Right now you are observer. This is coming towards your side. This hydrogen is also coming towards observer. See, badge line towards observer. So both of these are towards observer. They are on same side. They are same side. That's why they are known as syn. Syn means same side. But what I have told you, the anti one will eliminate out. Anti one. Who is anti? Just see who's anti. This is coming towards your side, and this is going away from you. This is going away from you, away from observer. Who is anti to this chlorine? This is anti. This is opposite side. So this will go eliminate out, even though carbon deuterium bond is stronger. Even though carbon deuterium bond is stronger, but then also it is anti, kids. But then also it will eliminate. It will eliminate. Why it will eliminate? Because it is anti. Because it is anti with respect to chlorine. Are you getting my point? This point, are you getting my point, kids? Do let me know if you are getting this point, what I have written over here, kids. Do let me know even though that bond is stronger, but that is anti, that will eliminate out, that is being anti, and that only will eliminate out. Are you getting my this point? So this will eliminate out with this. So deuterium will go, kids, this D plus will go with this Cl negative, so positive negative bond will get formed, and your answer is, that's why kids are losing marks, kids. They are not able to qualify the examination. This is the reason, because they don't know the mechanism, who got it for the first time. How many of you are able to understand? Do let me know in the chat section. If yes, I want to see green hearts, kids. I'm giving you quality content. Now the reason is why anti-elimination. The reason is why being anti-elimination. Remember that, kids. Thank you, Sahana, Lakshmi, Nimita. Now, see, kids, what is the need of anti-elimination? What is the need of anti-elimination? Just see. Why only anti-elimination? Question arises. Why only anti-elimination? $1 million question. Why only anti-elimination, kids? Now see, let me draw this compound, carbon carbon. I'm writing this side is halide. Chloride is coming towards your side. Chloride is coming towards your side, towards observer side. Chloride is over here. Why hydrogen is required just anti to this, and it should be planar? Just see, it is planar. If I draw one line, just see, is it planar, kids? It's planar to this. It is planar and anti. These two are opposite and planar. Anti-periplanar. Can you get it? Can you get it? These two bonds are planar and anti to each other. Are you able to understand? Rest of the two valencies, let me write down like this, but just focus on these two. They are planar. Kids, are you getting my point? See, let me write down, these two are planar and anti to each other. Planar, anti-periplanar. Can you get it? These are anti-periplanar. Now, why anti-periplanar is required? Why it is required? See why it is required. Just see to it. If this is, I am saying, this is bonding molecular orbital. This is BMO, because bond is formed over here. This is BMO, bonding molecular orbital. Then its ABMO will be on this side. Anti-bonding molecular orbital, that is vacant orbital. Vacant orbital will be on this side, kids. Now this hydrogen is there, that means its bonding BMO is over here, bonding BMO 2 electrons, bonding molecular orbital. Now kids, see, when K positive is going to approach, just see to it, kids. When K plus is approaching, what it will do? It will take this chloride along with the electrons. It is in need of electrons also. So this carbon will get slight positive charge. And the OH negative will come and it will try to take this proton only. It will lose its electrons, so it will get partial negative charge. Till now, is it clear? Simultaneous, the breaking of bond, and here the making of bond is taking place. From here breaking, here making of bond. Let me write down. This is a breaking of bond Bob, and this is making of bond Mob. Here this is making of bond Mob, and here breaking of bond simultaneous. Now this bond is breaking, this bond is breaking, this bond is breaking, Now this negative and positive, the pi electron, these pi electron will start sharing with this, and they are parallel to each other. They are being parallel to each other, then only the pi bond will get formed. If they are not parallel to each other, how the pi bonding will take place? This bonding can take place only when they are parallel to each other, and thought they are parallel, they have to be opposite. If this is on this side, if this have been on this side, then its ABMO must be present on this side, and they would not have formed the pi bond. For forming this pi bond only, they have to be anti-periplanar. If this is on this side, its anti-bonding means vacant orbital is over here, and this will overlap. Kids, to form this pi bond, these two should have to be present on opposite side. That's why anti-periplanar mechanism is required. Kids, how many of you got it? The reason. How many of you got the reason, kids, for the first time? Do let me know. First time, how many of you got this concept, kids? Do let me know. Now I will show you that thing, kids. If you got it, do let me know, kids. Kids, Baba wanna see in the chat section, you got it or not? If yes, then don't forget to show the green hearts, kids. Wow, kids. Don't think about dinner break. Right now I have not even started, kids. Let me start, kids. Now let me tell you the first example, kids. You are talking about dinner. What type of kids you are? See this example. Baba was over here. Baba has to tell you this reason, this example. Now see, kids. This is alpha carbon, this is beta carbon, this is also beta carbon. Now this is NCERT example. NCERT example. Right? Now the hydrogen can go from right hand side, hydrogen can go from left hand side. You will get two types of compounds. You will get two types of compounds. What are these two types of compounds? If hydrogen is going from here, this X negative, this positive, proton from here, delta negative, they will form a bond. So you will get CH3, CH double bond CH, CH3. If it is moving from there, you will get compound alkene like this, CH3, CH2, CH double bond CH2. Got it, kids? Halogen will move from here. After halogen, whatever the proton will go from here, will go from here. Kids, are you getting my point? If you're not able to understand, just see, if halide is moving, it will go by taking electron, it will create positive charge, and proton will move from here. If you're not able to understand, let me tell you, kids. Let me tell you. Don't worry, kids. Don't cry. See, CH3, CH, H, CH, X, CH3. Just see. It will take electron of carbon. Carbon will start trying, oh, my electron has been lost. What should I do? Feeling positive, donated electron, accessing, ah, I got electron, nalla iruku, yay. Now, once it has got electron, potassium has come to near to this. Hey X, I love you, I love you, I love you, I love your electron, I love you. Oh, will you form a bond with me? Yay. Now, the OH negative will come over here. Why only here? The halogen is attached to this carbon alpha and this is beta, then only they can form bond. OH negative is saying, hey hydrogen, I'm not interested in your electrons. You just keep your electrons with yourself. I'm interested in you only. So please come with me. I need you right now. Positive, negative, and there will be negative. Now they will say, oh, we will form a bond, we will form a bond like this, like this, like this, like this. Now more clear? Tell me, I will teach in this style only if it is more clear. Now the second compound, the second, this is the A part, the B part, just see. Na na na, na na na, this is halide, this is CH2H. Now they will eliminate out K positive, X negative, positive, OH negative proton, negative positive will form a bond. Now two types of alkenes you have got. One alkene, second alkene. You got it, kids? Just to let me know. Now you are wow, Saucy. Kids, do let me know. This way, Bond's love story. Bond's love story, you are liking it or not, kids? Tell me everyone. Understood. Okay. Now, let me tell you. Now, kids, what is the relation in between these two? If you see isomerism, 1, 2, 3, 4, 1, 2, 3, 4, they are position isomers. They are position isomers. So, E2 reaction is giving you two alkenes. Who is having more alpha hydrogens? See what are alpha hydrogens, kids? Double bonded alkene, neighboring carbon. This is neighboring carbon. This is known as alpha carbon. Alpha carbon, and neighbor to this alpha carbon. Whatever the hydrogens attached to these alpha carbons are known as alpha hydrogens. So there are 6 alpha hydrogen atoms. Now if you are able to understand, tell me how many alpha hydrogen atoms. Just enclose alkene. Just enclose this alkene. The neighbor on the right hand side there is no neighbor. On the left hand side there is one neighbor. And how many hydrogens it is having? 2 alpha hydrogen atoms. Right, kids? But there was one scientist who was not having knowledge of alpha hydrogen atoms. He was not having knowledge of alpha hydrogen atoms. He said the more substituted alkene. How to find out more substituted? If you see this alkene, there's this side one alkyl group, this side one alkyl group. It is disubstituted. Disubstituted alkene. And if you see this alkene, kids, only one alkyl group is there on this side. This is one alkyl group. So this is known as monosubstituted alkene. So disubstituted is more substituted, and more substituted alkene is known as Set-Jeff product. Which product? Set-Jeff product. Set-Jeff product. Remember that Set-Jeff product. Its another name is Jet-Sep. Jet-Sep. The second name is Jet-Sep product. Jet-Sep product. This is major alkene. This is major. This is major alkene. Remember that major. If I tell you the percentage, it is 80% form. And this is known as Hofmann product. This is known as Hofmann product. This is minor product. This is minor. 20%. Set-Jeff is major, Hofmann is minor. Kids, are you able to understand? Let me tell you once again. Let me tell you once again the same reaction. We took this reactant CH3 CH2 CHX, where X was not equal to fluorine, CH3, who was reacted with this, KOH, alcoholic, heat. Examiner will ask how many types of alkenes. The answer is 3 types of alkenes, kids. How many types of alkenes? 3 types of alkenes. What are these 3 types of alkenes? Just see. That's why I am writing once again. This is the reason why I am writing once again, kids. One product is CH3, CH, double bond, CH, CH3. Another product is CH3, CH2, CH, double bond, CH2. Now, this is set-Jep product. Remember that this is what? Set-Jep product. I have told you this is also known as Jet-Sep, 2 names, just like Mohandas Karamchand, Gandhi, then Bapuji. 2 names. Hofmann product, less substituted is Hofmann product. Who is Hofmann, kids? Less substituted is Hofmann. More substituted is Set-Jef. Remember that these 2 are of isomers of each other, and once these 2 are isomers of each other, remember that one is major, one is minor. This is being major, this is being minor, kids. This type of formation, whenever more than one type of alkenes are formed, one is major, rest are minor, 1, 2, 3, whatever the number of minor, such type of E2 reaction is known as regioselective. What do you mean by regioselective, kids? Regioselective. What term I am using? E2 reaction is regioselective. I will tell you the meaning of regioselective. When one of the structural isomer is formed in major amount. What do you mean by regioselective? When one of the structural isomer is formed in major amount, Remember that, major amount, kids. And see, this double bond cannot show GI, can't show GI, but my dear students, this will show GI, and that's why it will exist in 2 forms. One is transbutene, another one is cis-butene. Remember that, cis-butene. Who is major? This is maximum one, kids. Major one. So these 2 are stereoisomer. This is trans, this is cis. Why cis? Both the hydrogens are on same side, and that's why E2 reaction is known as stereoselective, because this trans and this cis, they are stereoisomers, and that's why E2 reaction is known as E2 is stereoselective also. Stereoselective. What do you mean by stereoselective? When one of the structural or stereoisomer is in major amount. So regio, word regio is related with the structural isomerism, and the word stereo is related with the stereoisomer. So E2 reaction is regio as well as stereoselective. This point is clear, this reaction is clear. If yes, I want to see green hearts, kids. If it is clear to each and everyone, do let me know. Kids, do let me know, because I need only intelligent students, those who are interested in rank, not everyone. I'm not interested in the mass kids. Baba is interested only in those students, those who are actually in need of rank. I want to teach only those students. Very good kids, very good. So Madhumita, very good. Mohammed Asfaq. Now kids, see, let me explain this with another example, but see to it. If I take kids another example, just see another example kids. Let me take another example to explain this. Suppose if I say that I have got this reactant, here chlorine, here methyl, right? Here chlorine, here methyl. Now what you are supposed to do? This halogen is alpha carbon, this is beta carbon, and this is also beta carbon adjacent to this. Padosi means neighboring carbons are beta. Now see, the hydrogen can eliminate out from here also, and the hydrogen can eliminate out for here also. From both the two positions, this proton can eliminate out. So in this way, what you will get? Here you will get delta positive, here you will get delta negative, there also you will get delta negative. So if you react it with KOH, alcoholic and heat, you will get two types of alkenes. One alkene is like this, double bond at this place. Second alkene you will get like this, double bond at this place. What do you think? Which alkene is being more substituted? If I say this is being X, this is being Y, what do you think which is more substituted? Now what you do to find it out? You see carbon, double bond carbon. Now this side one alkyl group is moving. See, just let me tell you in a better way so that everyone can understand. One alkyl group this side, one alkyl group this side, one alkyl group this side. So you can see it is tri-substituted, three side, because there is hydrogen. One is hydrogen, so don't count this hydrogen. Don't count this hydrogen, the blue one. One alkyl, one alkyl, one alkyl, tri-substituted. Are you getting my point, kids? Tri-substituted. Now if you focus over here, one alkyl this side, another alkyl this side, because rest of the two are being hydrogens. Rest of the two are being hydrogens. So it is di-substituted only, kids. These two are being hydrogens. So this is di-substituted. Who is being more substituted? Definitely this. So this is your Set-Jeb product. Set-Jeb product. And that is your Hofmann product. So who is going to be the major? Examiner will ask. So this one is major. Everyone got it, kids? Clear? Now let me give you third example. Now see, this is very, very important example, kids. And before giving you this example, let me tell you one very, very important note. Very, very important note. What is that note, kids? In E2, Hofmann product is major product. Major. Except the following three cases. Except the following, how many cases? Except the following three special cases. In these three special cases, either Hofmann or Setjeff can be major, What I'm saying, kids, otherwise Hofmann is major, but if I talk about these three special cases, kids, remember that Hofmann or Setjeff can be major. Are you ready? Kids, how's the Josh? I can't see the Josh is high, kids. I don't know. What do you want? Why the Josh is less, kids? Let me see in the chat section why. What's the reason, kids? Kids, first of all, do let me know how and why the Josh is less, kids. How's the Josh? Kids, first of all, make a promise that you are with... No, right now I can't give you the break, kids. I have to teach. Kids, I want to see your Josh, kids. Then only I can tell you each and everything, kids. Don't worry about the strength. Baba never worry about the strength, kids. Baba want to teach only quality students. Baba never cares for the strength. Don't worry, kids. Baba is never running after the strength or views. Just see now. Special case number 1. Very, very special case number 1, kids. When fluorine is leaving group, remember that when fluorine is leaving group, what is going to happen? See, kids, everyone just see to it. Remember that, my dear students, carbon belongs to second period, and fluorine also belongs to second period. Carbon to second, fluorine to second, very, very strong bond, will not break easily. This bond is being very, very strong bond. Will not break easily, right? So, in front of this, any strong base, if you bring NaNH2 and heat, that is sodamide. Let's see what you are going to get, which will be the major product. Now, let's see, kids. If this is not going to break, then who will get eliminated out from carbon? Let's see, kids. If I tell you this reactant, just see to this and let me write down in a proper way so that you can better understand. CH3, CH, one hydrogen, fluorine, this bond will not break easily, very, very strong bond. CH2H, now see to it, kids. NH2 negative will come. This is alpha, this is beta, this is beta. I hope that everyone is able to understand. NH2 negative will come and it will take away this proton, kids. It will take away this proton. So charge will come over here, or NH2 negative will come at this place and will take away this proton. So partial negative charge will come. Now, Na plus is also there, but fluorine, this fluorine is saying I'm not interested because my bond is very, very strong, very, very strong bond. So fluoride said no, I will not go. Now, kids, In the earlier cases, when chloride, bromide and iodide were present, there was simultaneous breaking and making of pi bond was taking place. But in this case, kids, only partial negative charge is formed. So remember that in transition state, partial negative charge is there, partial negatively charged carbanion is formed. Carbanion is formed. So remember that, my dear students, rate of reaction is directly proportional to stability of carbanion, and carbanion stability is like which carbanion is most stable, kids? Carbanion which is stabilized by resonance, carbanion stabilized by resonance is more stable than 1 degree, then 2 degree, then 3 degree. Remember that this is the stability of carbanion, kids. Carbanion which is doing resonance, then 1 degree, then 2 degree. This is the stability order, kids. This is the stability order of carbanion. Remember this, kids, right? Now the rate of reaction is directly proportional to stability of carbanion. So let me write down this point, kids. Rate of reaction is directly proportional to stability of carbanion. Remember, this is $1 million point, kids. This is very, very important thing, that rate of this reaction is directly proportional to stability of carbanion. You have to keep this point. Now see, this is not having resonance, this is also not having resonance. Both of these two are not having resonance. Then who is going to be more stable, kids? This carbon is attached only with one carbon, so this is 1 degree carbanion, and this carbon is attached this side also with carbon and this side also with carbon, so this is 2 degree carbanion, kids. So this is more stable, so this alkene will be more formed and this will be less formed. Remember that. Don't see the stability of product in this case, see the stability of carbanion, kids. In this case you have to see the stability of carbanion, and the stability of carbanion says that this time this Hofmann product will be major formed. Although this is unstable, but this will be 80%. Hofmann product is major, kids. Hofmann product is major right now. Major, kids, major. Hofmann product is major this time, and ZJ product will be minor, kids. It has turned to be upside down. That ZJ product is minor, kids. ZJ is minor, Hofmann is major. Now everything got turned out. Now Hofmann major, ZJ minor. This time no need to consider the stability of the product. Who is going to decide the carbanion stability? I hope that you got this point, kids. Very, very important point. But in maximum of the books, only one example is given. So students, always think about that. That Hofmann product is always major whenever fluorine is given. But don't think like that. Let me show you. Let me give you another example. Just see another example. If I write like this, kids, see. If I write here benzene CH2, now CHF CH3. Now once again you see what will happen, kids. If I write like this CH2H, now NH2 negative once again will come. it will take, this is alpha carbon, this is beta carbon, adjacent to this is also beta. The NH2 negative will take away this proton. It will take away this proton, kids. Proton. It will develop partial negative charge. NH2 negative will approach to this carbon also. It will take away this proton. It will also develop negative charge. Now see, kids. This carbon is attached only with one carbon, so the degree is 1. But this carbon is attached to this carbon also and this carbon also. Its degree is 2. It is 2 degree, but this is doing resonance with phenyl. Remember that whenever negative charge is with this benzene, it will do resonance. So it is stabilized. This negative charge is stabilized by resonance. I hope you are getting it. Stabilized by resonance. Now this is stabilized by resonance, so this is more stable. This carbanion is more stable. More stable, so more formed, kids. More stable, so more formed, and more formed, that means more responsible for major product. More responsible for major product. For major product. Now see, kids, this once again Sedgwick product. So no need to cram it out, kids. It's a $1 million concept. I don't think that everyone can understand, but those who are really want to secure good rank, they can understand it, kids. Now, who is the major product now? Once again, you see the Sedgwick product has turned out to be the major product. This is Sedgwick because it is more substituted. Sedgwick is major and Hofmann is minor. So what do you think, it's this organic chemistry is to be crammed or to understand? So definitely you have to understand it, kids. Understand it, because see, in both the two cases fluorine is the leaving group. Here the fluorine is the leaving group. Here the fluorine was the leaving group, but who was the major product? You have seen Hofmann was the major product, you see. Here the Hofmann product was the major. Just see, Hofmann was major. But if you see here also, fluorine is the leaving group, but who is major? Sedgwick is the major. So no need to cram it. Who has decided who is major? Product stability doesn't matter. Carbanion, and not the carbanion, partially charged carbanion, because there is no intermediate formation. There is just transition state. The carbanion, partial carbanion, is formed in the transition state. You got it, kids? Let me see in the chat section that how many of you got it, kids. But you have wrote Hofmann is more stable. No, kids. Remember that Sedgwick is more stable. Where I have written Hofmann is more stable? No, where I have written Hofmann is major, Hofmann is more stable. Where I have written? Nowhere. Which kid is writing SMW? SMW. Nowhere I have written Hofmann is major. See, means stable. Here Hofmann is major. I have not written stable. Remember that SMW, what I have written? Hofmann product in this case is major, not stable. Although it is unstable. Although it is unstable. Although it is unstable. I have written it is major. I have not written it is stable. Although it is unstable, but then also it is major. Although this is stable, although it is more stable, then also it is less. That is the science, kids. I am trying to tell you. This is the most important point, kids, which I am trying to tell you. Kids, try to understand. That is unstable, but then also major. Just see, that is unstable, but then also it is a major. It is more stable, but then also it is a minor. This is the point to be noted, my lord. Kids, are you getting my point? Stability means something else and formation major means something else. Let me tell you, whenever we are dealing with, note, write down note. In case of X equal to fluorine, never see the stability of alkene. Never see the stability of alkene. We have to always focus on stability of partially charged carbanion, partially charged carbanion in transition state. Rate of reaction is directly proportional. Rate of reaction is directly proportional to stability of carbanion. Stability of partial carbanion in TS. TS means transition state. This is the point to be noted, my lord. Everyone, I have written that major is Hofmann. I have not written that that is the more stable. You got it? Kids, are you able to understand? This is the $1 million thing. No one is going to tell you, kids, what I am teaching you, what I am telling you, kids. Try to understand. Everyone got it? If yes, show me the green hearts. Stability means major product formation means something else and stability means something else. SMW is writing, sir, in more previous slide that you have written that Hofmann is major in general case when please set the floor. Let me see. This one, when fluorine is leaving group, then Hofmann product is major. Yeah, if there is no fluorine, remember that. If no fluorine or Hofmann exhaustive elimination, then ZJF is major. Then ZJF will be major. But these three cases, anything can be major. Either Hofmann or ZJF, anyone can be major, right? In these cases, anything can be major. In E2 reaction, Hofmann product is major. In these cases, or whenever fluorine or He is there, right? So, if you are getting confused, let me write down like this. Don't worry, kids. Don't worry. Let me write down. If anyone is getting confused, let me write down like this, kids. These three places, if you are talking about these three cases, anything can be major. Either Hofmann or ZJF, anything can be major. These three special cases, either ZJF, that is Jetsev or Hofmann can be measured depending on the situation. Either Sedgev or Jetsev, that means same, or Hofmann can be measured, right? Depending on the situation, depending on the situation. Now I think it is clear. Let me see. Now it is clear. SMBM. Now is it clear? Where you have gone? Bacha, now let me know. Is it clear now? And let me write down this except. Let me remove this except in the following. In the following three cases. Now I hope this is clear. In the following these three cases. Now is it clear, kids? First of all, do let me know SBM, SMV, clear? Thank you, kids. Thank you for thinking about me. Okay, now see. The first case I have told you when fluorine is the leaving group, kids. When fluorine is the leaving group. Now the second case, first let me give you one question, kids. Let me give you one question. See, if I give you question like this, that here is chlorine, here is methyl. Another question like this, here is fluorine, here is methyl. Now see, kids, KOH, alcoholic heat, KOH, alcoholic heat. Now what do you think will be the major product in these two? A, B. Major product will be same or different? Do let me know. Major product will be same or different, kids? Do let me know. Major product will be same or different? Now see, this is alpha, this is beta, this is beta, this is alpha, this is beta, this is beta. But see, this is fluorine and this is chlorine. Here simultaneous breaking and making of bond, and here partial negative charge will develop. This is attached with how many carbon? Just see, 1, 2 and 3. So this is 3-degree carbanion. This one, 1 and 2, 1 and 2. So this is going to be 2-degree carbanion. So this is more stable, kids. Now see, in this case your major product will be this one, kids, and in this case your major product will be this one. I hope that this is very clear to all of you, that in this case your Sedgev product is major, but in this case your Hofmann product is major. And in that case your Hofmann is minor, kids, and in this case your ZF is minor, kids. ZF is being minor. I hope that everyone got it. Agreed, kids? Just see to it. Agreed? If yes, do let me know. Agreed, kids? Everyone just do let me know, agreed or not. Fast, fast, kids, do let me know, fast. Everyone, kids, do let me know, got it or not. Now, the second reaction, second type, let me tell you, the name is Hofmann exhaustive elimination. Get see to it, Hofmann exhaustive elimination. Hofmann exhaustive elimination. We call it he. How to find it out? He. It's how to find out this he. Remember that the specialty about this is the reactant must be quaternary ammonium salt, quaternary ammonium salt with at least one beta hydrogen atom, with at least one beta hydrogen atom, plus strong base is required. And what else is required, kids? Heat is required. Its mechanism will also move like the partial negative charge, like the first case. Partial negative charge like the first case, kids. Partial negative charge. Thank you, kids. Thank you, Sana. Partial negative charge in the carbanion. It will also move like the first case. Rate of reaction directly proportional to carbanion. Which carbanion? Partially charged. Carbanion in transition state. Now, kids, don't think like that the intermediate will form. This is the transition state, not intermediate. No intermediate formation. Right, kids? Now, let me tell you this reaction. Just see. Let me tell you this reaction, kids. The first well-known example of this reaction is, just see to it, nitrogen. I will write methyl. I will write down methyl and CH2H. You see hydrogen I have. Now here I will write CH, H and CH3. Now just see, kids, it is having positive charge. So one halide will be there outside the house. Now just see to it. Now I will bring well-known base, strong base, which you will get always in the examination, H2O plus heat. Right, kids? Right? Now, this is the nitrogen. This is alpha carbon attached to this, This is alpha, but you see this is beta and this is beta. Now in beta, that strong base is interested. The strong base will come and will say, hey, I need your proton. It will take this proton, negative charge. It will take this proton, negative charge, so negative. So this electron will come to this side, and these electrons will start moving like this. Now this nitrogen will take away the electron of this carbon and will move after getting charge, electron density, electronic repulsion. Due to electronic repulsion, kids, nitrogen will take this electron and positive, negative, this side bond, this side bond. But see, this is carbon attached only with one carbon, so 1 degree carbonyl. This carbon, that side also, this side also 2 degrees. So this carbonyl is more stable, more formed, more responsible for major product. So more stable, more formed, more responsible for major product. So you will get this nitrogen as 3 degree amine, kids. 3 degree amine, 1 alkene you will get like this. This is minor, kids. This is minor ZJ product. It's not minor because of ZJ product, because its carbonyl was less stable, that's why it is minor. Once again I am telling you, kids, remember that this is more stable, but here stability is not going to decide which one is minor, which one is major. If I have written minor, it doesn't mean this is less stable. Remember that this has been formed more in major amount because its carbonyl is less stable. Less stable carbonyl, less amount formed. Its carbonyl is more stable, so this is more formed, kids. Once again I am telling you that more formation doesn't mean that is more stable. So this is Hofmann. Here Hofmann is major, ZJ is minor, kids. I hope that everyone got it. It is just like the case number 1. Your understanding, my prime target is your understanding, kids. Do let me know. Once again I am telling you that here the one which is formed in major amount doesn't mean it is more stable or less stable. Here the carbon ion stability is going to decide. Kids, do let me know, kids. Everyone, are you able to understand or not? If yes, keep on showing green hearts, kids. If you are really able to understand, I want to see green hearts, kids, because your understanding is my prime target. Wow, thank you, kids, thank you. Very good, kids. Now see, once again if I give you another one, see, just try it out. If I give you compound like this, nitrogen, methyl, CH2, C6H5, just try your brain, kids, what you are going to get. On this side I have not written any chloride. See, some trees are there, something is there already which is having oil. If the tree is containing oil within itself, there is no need of extra oil to put on oil. It will burn itself. So OH negative is already there. Simply I have to heat it. Now what you have to think, it's how you will see what is going to get formed. See, my dear students, this is nitrogen, this is alpha, no beta hydrogen, no beta, nowhere beta. This is alpha, this is beta, and this is also beta. But if you see, kids, this will form primary 1 degree carbanion. It will form 1 degree carbanion, and my dear student, this will form 2 degree carbanion. But see, adjacent to this there is phenyl. Remember that whenever there is phenyl says I will do resonance. So stabilized by resonance, and whenever there is a resonance, kids, that is more stable. So see, this nitrogen will take away this electron. So positive, negative, bond, positive, negative, bond. Now see, two types of product, kids. Nitrogen with lone pair CH3. Now see, kids, this phenyl, and this product is going to be formed in major amount. Now CH double bond CH, CH3. Now see, both the two types of products I will draw, kids, and just try to check it out which will get formed in major amount. See, kids, definitely this carbanion was more stable, so more formed, so more responsible for product formation. So this will be major, kids, and this will be minor. Now let me check it out which one is Sedgwick, which one is Hofmann. Just see, kids, if I try to find out which one is Hofmann, which is Sedgwick, how to check it out? Just see, kids, this side one alkyl and this side one phenyl, disubstituted. It is being disubstituted, and this only one alkyl mono-substituted. So which one is more substituted, kids? This is more substituted. So definitely this is going to be your, Sedgwick, and this time Sedgwick is major, and this side Hofmann is minor. So nothing to do with the stability of product. This is the stability of carbon, and now I am going to give you one question. Try it out. I hope that this is clear to each and everyone. This is clear. Now the question which has been asked in AIMS examination, see to it. This has been asked in AIMS examination. Nitrogen, methyl, positive charge. Now chloride, Ag2O heat, Do let me know what's your answer. Tell me what's your answer, kids. Let me check it out. What's your answer, kids? Yes, kids, do let me know. What's your answer? Now see, kids, this is nitrogen, this is alpha carbon, this is alpha carbon. Useless, no beta. So if I say this is alpha, this is beta, say in this side this is alpha, this is beta, and on beta there we have got hydrogens. See, we have got hydrogens. So the base will come, base will take away one proton, because base is negatively charged. Base will take away this proton. Negative charge will get developed, and this will start donating electron through plus I, and this will withdraw electron, and what you will get? You will get here positive, and positive negative will form bond. They will form bond, and what you will get? See, nitrogen, methyl, this type. I hope you got it. Everyone got it. It's crystal clear to each and everyone. Now AgCl and the base with H, AgCl, you will get like this. This is the product, kids. Now see the case number 3. Till now if it is clear, then I will go with the case number 3. Let me see your reaction in the chat section, kids. Do let me know. Till now it is clear to each and everyone, kids. Right now, no break, kids. Everyone just do let me know. Let me cover it up, because your selection is my priority, kids. I need your selection. Madhumita, very good. Herobrine always writing once again. Herobrine always writing once again. What is this, Herobrine? Likita Mala, very good. Now see, kids, clear to each and everyone. Right now, let's see case number 3. Case number 3 is Buppy-Larry case. Why I call it Buppy-Larry case, I will let you know. Champa case, Champa chain snatching case. I call it chain snatching case. Case number 3. Always Hofmann is major. This I call it like Champa's chain, golden chain has been snatched by somebody. Okay, chain snatching case. Now see why. If I tell you kids, there is one Champa, she is having golden chain, golden necklace, half kg golden necklace. It's flowing like this, golden necklace. And there is one Alia. She is having, Champa was having half kg only, half kg golden necklace. But Alia is having 2 kg golden necklace, 2 kg. Now kids, which is more costly? Definitely Champas or Alias. This is Champa, that is Alia. Definitely Alias is more costly. But chain snatchers will eliminate out whose golden necklace is easy to be snatched. Do let me know in the chat section whose golden necklace is more easily can be snatched. Kids, do let me know which golden necklace can be easily snatched. Do let me know, kids. Everyone just do let me know which golden necklace is easy to be snatched. Everyone just do let me know. Kids, taking too much time. Kids, you are taking too much time. Do let me know fast, quick, kids. Champa's necklace can be easily snatched because Alia's necklace is tough to be snatched. This necklace is tough to be snatched because it is sterically hindered, Now this special case number 3 is dealing with this story only. This story will give you a lot of information about this case. Just see. Case number 3 says, have you seen Spider-Man movie? There was one Spider-Man, sleek, slim and trim. Zoom, za, zoom. He was moving like this. There was one octopus with tentacles, Dr. Octopus with tentacles, too much sterically hindered. So whenever base is like this, whenever base is like Dr. Octopus, CH3, okay. Remember that they can give you this base like this, or they will give you this base like this, CH3 whole thrice, COK, or they can give you like this, TBUOK, or they will write down potassium tertiary butoxide, They can give you in any form. Remember that. This is too much sterically hindered base, like Dr. Octopus. Too much sterically hindered base. Now, once there is too much sterically hindered base, it will not be able to reach up to the very finest place. Just see where and how. See, kids. If I give you compound like this, CH3, CH3, CHBr and CH3. Now let me draw this hydrogen like, let me mark this hydrogen and let me mark this hydrogen. Which hydrogen can be snatched easily, kids? Let me draw it particular on the basis of these carbon and hydrogen so that you can easily understand, because they are being tetrahedrally located like this. Now which hydrogen can be easily snatched? That hydrogen or this hydrogen? Why I am focusing on these hydrogens only? This is alpha carbon, this is beta, this is beta. So I am focusing on this yellow hydrogen and I am focusing on that green hydrogen, which can be easily snatched by this base because it is too much sterically hindered. So this base will find easily it can snatch this proton. Easy attack, it is easy attack. This is Champa's golden necklace, and he will find this hydrogen to attack, because if he is coming like this or he is coming like this, tough to be snatched, very tough to be snatched. Am I right, kids? Very tough to be snatched. That is can be easily snatched. So definitely this proton will eliminate out like positive and negative here and positive. So this alkene will be formed in major amount. Can you see, kids? So I will say CH3, CH3, CH double bond CH and CH double bond CH2. This will be major. This will be major and this will be minor. Minor. Now kids, this is tri-substituted, this is ZF, then also minor, kids. That is Hofmann, but then also major. All these three special cases I think that you got it, kids. Now this is not only the chemistry of class 11th. Kids, wow, Saucy, thank you. Kids, do let me know that you got it or not. Everyone, just do let me know. Is it clear to each and everyone? Yeah, I will. Either I or Wasim sir. Kids, first of all, Hamis, welcome. Do let me know everyone got it or not. Very good, very good, very good. Now, let me tell you, even then it will be fit and fine. Even reaction. Till now I taught you E2. Now let me teach you E1. Now E1, kids, even elimination follows first order kinetics. Let me tell you, kids, you are not just studying your hydrocarbons, alkene and alkynes. If you have a little bit of knowledge, there are a number of students who will let you know that, kids, your half of the portion of class 12th haloalkanes and haloarenes is also getting completed, kids. They know very well. They know very well half of the portion of class 12th organic chemistry is getting completed here, kids. follows first order kinetics, that is rate of reaction R is equal to K dependent on reactant's concentration but not depends on reagent's concentration. I will say reagent concentration to the power 0, reagent raised to power 0, and this is first order kinetics, that rate of reaction dependent on whom? Gets rate of reaction depends only on the concentration of alkyl halide and not on the concentration of reagent, that is the base. That means it is a complex reaction. This line is indicating that it's a complex reaction. It's a complex reaction, and complex reaction means will take place in more than one step. And more than single step means that rate of reaction is directly proportional. Rate of reaction directly proportional to stability of carbocation. Stability of carbocation. And carbocation formation means rearrangement may take place. Carbocation formation means rearrangement may take place. Rearrangement may take place. May take place. Now kids, first of all let me introduce with the rearrangement. I hope this point is clear. This has come from the chemical kinetics. Now types of rearrangements. Let me tell you kids, types of rearrangements. Are you ready? Everyone ready? Types of rearrangements. First type of rearrangement is 1,2 hydride shift. 1,2 hydride shift. What is going to happen over here kids? Just see. If I write down this compound like this, halide. Now why this reaction will take place in more than one step? One question arises, because in even reaction, if I talk about in this even reaction kids, in even reaction, if I talk about this reaction, what is responsible, why this reaction is going to take place in more than one step? First question arises like this. Let me make that point very clear. In even reaction, base is weak. What do you mean by weak base? Like ROH in presence of polar protic solvent. Now what polar protic solvent will do? Polar protic solvent will come to Rx. Just remember that Rx, like polar protic solvent, if I say water, which is polar as well as can donate polar and can donate proton, and can donate proton. That means polar protic solvent can donate proton. Now water is interested, you see, this is having negative charge, this is having positive charge, and water is being polar, like dissolves like. So it will take away this halide and you will get carbocation. Carbocation formation always means think about rearrangement. Carbocation formation always gives an idea. Always think about rearrangement. Always think about rearrangement. I am not saying always do rearrangement. Always think about rearrangement, because rearrangement may take place. Means if it is getting more stability, then only it is going to take place. If it is getting less stability, it will not take place. Even if it is getting same stability, it will not take place, kids. So always think about rearrangement, kids. Rearrangement. Whenever carbocation is formed, always think about rearrangement. Kids, remember that carbocation formation gives an idea about that you have to think about rearrangement. So see, what I was going to tell you, this was the carbocation, and if you are adding water to this, if you are adding polar protic solvent to this, this polar protic solvent will take away this chloride along with its electron. Heterolytic cleavage will take place and you will get this carbocation. Now this carbocation formation is telling you that what's your stability, dear? Hey dear, how much stable you are? This will say, oh, I'm having no resonance, no resonance, resonance ille, resonance ille, no resonance. Bhaiya, resonance nahi hai, there is no resonance. I'm not having resonance. Oh, so are you stabilized by hyperconjugation? Yes. How many alpha hydrogen do you have? See, 3 over here, 1 over here, 4 alpha hydrogen atoms. So I'm stabilized by hyperconjugation. Do you have any inductive effect? Yes. From two sides, carbons are helping to me. So my degree is 2 degrees, so I am stabilized by inductive effect. Kids, I think your GOC is not completed, so little bit problem you must be feeling, kids. Am I right, kids? Without GOC, you are able to understand what is SBH, what is SPI. Let me write down, kids. SBH means stabilized by hyperconjugation. SBI means stabilized by inductive effect. Kids, are you getting this point or not? Stabilized by hyperconjugation is stabilized by inductive effect, kids. Are you getting this point? First of all, do let me know. Let me see, kids, whether you are, I think you should know a little bit of hyperconjugation and inductive effect. Kids, everyone just do let me know. Everyone, please. I need your answer. Do you know a little bit about hyperconjugation and inductive effect, kids? Wow, Sahana, Sausi, Romba Sulvam, Bhuvneshwari, wow. Kids, very good, very good, very good, very good. This is basic organic, kids. This is basic organic. I know that you can understand. Otherwise, I will let you know. Now, kids, if this is asking, hey hydrogen, if you come over here, this carbon is asking, inge va, and this carbon is saying, poda, go over there, cha. So once this hydrogen is shifting to the second carbon, adjacent carbon. Hey, come over here. Why should I come? Why should I come? Just come over here. I will let you know. I will let you know what benefit we are going to get. Now let me tell you on the second page the same thing. Let me continue on the second page. This was earlier like this, kids. It was earlier like this. It was like this. Now if this hydrogen is moving along with the electron, if this hydrogen is moving along with this electron, this is known as 1,2 hydride shift. Why 1,2 hydride shift? Because from one carbon to second carbon it is moving. It is known as what? Say what? 1,2 hydride shift. 1,2 hydride shift. Now why it is moving? $1 million question arises. Why it is moving like that? Who is making it? What driving force? Now see, kids. CH3, C positive, CH3, CH2, CH3. Now see, kids, this was having 3 and 1, 4 alpha hydrogen atoms, and this was stabilized by hyperconjugation. It was having 2 degree and stabilized by inductive effect. By doing so, now this 3 adjacent to this 3 and 2, 3 plus 3 plus 2, 8 alpha hydrogen atoms. So more alpha hydrogen. It was having just 4 alpha hydrogen atoms, only 4. Now this is having 8 alpha hydrogen atoms, more alpha hydrogen atoms. Now this is attached with 3 carbons, so its degree is 3. So 3 degree, 3 degree. So it is more stabilized by hyperconjugation at was 3 degree carbocation. So more stabilized by inductive effect. Now kids, which carbocation is more stable? That is more stable. So the equilibrium will lie more toward that side, more stable, more formed, more stable, more formed, more responsible for major product formation. Major product formation. I hope that you got it. One-two hydride shift is clear to all of you, kids. 1,2 hydride shift is clear to all of you. You got it? Everyone, you got it? 1,2 hydride shift, Mindex. What is inductive effect? It's a very basic effect. Let me tell you, inductive effect. They are donating, they are helping with the electron. Methyl is donating electron. So plus I means electron donating group. They are donating electron. They are electron donating group, and they are helping from 3 sides. From 3 sides, they are donating electron. They are saying, hey, have some laddus, have some son papdi, have some rasgulla, balushai. From 3 sides, they are doing friendship. In this, only from 2 sides, they were helping. See, this help from this side and this side. Only 2 sides they were helping. You got it? From 3 sides they are helping through plus I. More stable. Now after this, let me tell you hydride shift. After the hydride, let me tell you methyl shift. Right now I have told you hydride shift. Now let me tell you 1,2 methyl shift. See to it, kids. One, two, methyl shift. Suppose if let me write down one compound like this. Now it has been placed in ethyl alcohol and water. both are being polar protic solvent. So these PPS, polar protic solvent, will come to this bromide. This bromide is negative, carbon positive, like dissolves like. So water will take away this bromide. It will get positive charge. Carbocation formation will take place. CH3, 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 CH positive, CH3. Now think about this carbocation kits. How many alpha hydrogens are there? If you want to check alpha hydrogens, what you want to see, kids? This carbon and adjacent carbon is this and this. It is not having any alpha hydrogen, but this is having 3. So stabilized by hyperconjugation, only 3 alpha hydrogen atoms. Now how many friends? That is plus I. How many plus I are there? Just see. 1 plus I from this side, 1 plus I. Plus I means electron donating group. Plus I means what? Electron donating group. Electron donating group 2. So it is 2 degree stabilized by inductive effect. Now, now kids, if this methyl is moving along with electrons, if methyl is moving along with the electrons, see, if this methyl is moving to the adjacent carbon 1 to 2, we will say 1 to methyl shift. We will say 1 to methyl shift, kids. We will say 1 to methyl shift. Now let's see whether its condition will get changed or not, whether it will feel happy or not. See, kids, CH3, it has taken electron plus charge at this place. CH3, CH3 and CH3. Now see, kids, how many alpha hydrogens? Do let me know how many alpha hydrogens. 3, because adjacent one is this one, this one, this one. 3 and 1. 3 plus 3 plus 1. 3 plus 3 plus 1. 7 alpha hydrogen atoms. More alpha hydrogens, so more stabilization by hyperconjugation. Now how many plus I, kids? 1 friend, 2 friends and 3 friends. So 3 degrees, so stabilized by inductive effect. Who is more stable? That one, earlier one, or this one? Definitely this one is more stable. So more in the forward direction, more stable, more formed. More responsible for major product formation. Till now, is it clear? I hope this is clear. Do let me know in the chat section. Then I will tell you ring expansion kits. Then I will give methyl plus hydride shift questions. Okay. Let me give you some questions on demand, huge demand. So kids, whatever you want, I will provide you. Okay. Okay, let me provide you question. Whatever you want, you just do let me know. Question is, which will show one to hydride shift? Secrets. A, B, C, D, none of the above. Nota means none of the above. So what's your answer? Let me see in the chat section. What's your answer, kids? Tell me what's your answer, kids. Do let me know what's your answer, kids. C. South C is going with C. But the answer is wrong. Answer is wrong. Only the correct answer is, kids, B is the correct answer. Remember that when the charge is on the ring, there is no ring expansion. Let me see, kids. There, here, okay. So there are two answers, kids. One answer and two. These two. See, right now it is 2 degree. Once it is moving, this 1,2 hydride shift is going to take place. It will become 3 degree, kids. It will become 3 degree. So hydride shift will take place. This is CH plus. If this 1,2 hydride shift is going to take place, this will become 3 degrees. So here also 1,2 hydride transfer will take place, kids. It should be like this. Now in this, it is stabilized by dancing resonance. There is one dancing resonance you will study in GOC, already stabilized by dancing resonance. So no shifting will be there, no shifting will be there. So these are the two answers. Kids, got it? Should I give you another question? Should I give you? Oh, South C, you said A and B. Oh, ho, ho, ho. Yeah, very good, South C, very good. Now, kids, should I give you another question? Are you ready for another question? Now, the question is, which will not show 1,2 hydride shift? The question is now, which will not show 1,2 hydride shift? Question is now, which will not show 1,2 hydride shift? A, B, C, D, what's your answer, kids? Let me see in the chat section. What's your answer, kids? Let me see. Everyone, do let me know what's the answer here. Which will not show 1,2 hydride shift? My question is, which will not show 1,2 hydride shift? Ramesh, Saundhar, very good. Now, the correct answer is C. Here, no hydrogen. So, in this case, there is 1,2 methyl shift. There is 1,2 methyl shift. No hydride shift. So, this is the answer. If you talk about this case, this hydrogen will move, it will show. Here, this is 1 degree, this hydrogen will move, it will show. This hydrogen will move, this will show. So, A is the correct answer, kids. A is the correct answer. Got it? Do let me know you got it or not, kids. Everyone just do let me know you got it or not. Now, another question. Last question. Which will neither show methyl shift nor hydride shift. A CH3 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 CH2 plus, B CH3 CH CH2 CH3 CH2 plus, C D What's your answer, kids? This is very good question. Let me check it out. What answer you are going to give, kids? Tell me. Everyone just to let me know what's the answer. Everyone just to let me know. At 10 o'clock, 10 I will give break. At 10 I will give dinner break, kids. At 10 p.m. I will give dinner break. Namita Madhu is going for C. Madhumita is going for C. Ramesh done wonderful job. Jitu, Dar Arfat, D. D is the correct answer, kids. D is the correct answer. D is the correct answer. See why? In this, methyl shift will take place. 1,2 methyl shift. In this, 1,2 hydride shift. Now in this, 1,2 hydride shift will take place. In this, already doing resonance with phenyl, stabilized by already stable. Already it is being stable. So no shifting will be there. No shifting, kids. I hope everyone got it. Everyone got it, kids. Now let me teach you even reaction, and at 10 I will give break, dinner break. Okay, kids? At 10 I will give dinner break. Now E1 reaction. In this reaction, ZF product is major always. ZF, your friend ZF, also known as say ZF, is always major. Now my dear students, let me give you wonderful example of this reaction. See, if I am having this compound, just think about this: CH3, 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 CH2Cl. Now if I would have reacted with KOH, alcoholic heat, No reaction, kids. No reaction at all. No reaction would have taken place at all, kids. No reaction, no reaction. Why? 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 Question arises, why? See. This is alpha carbon, this is beta carbon. There is no beta hydrogen. That's why no reaction. At this place, there is no hydrogen. Just see, it is attached with methyl. Methyl, methyl. At this place, there is no hydrogen. So, no beta hydrogen. So, you know that this reaction is E2 and takes place in single step, but there is no beta hydrogen. But if the same reaction, if I carry out with ethyl alcohol aqueous heat, now what they are doing, their mechanism is different. They do everything through E1. Now what they will do, they will take out this chloride. Water will take away this chloride and will form carbocation. It will form carbocation. Now see, the scene will move like this. The scene will move like this. Just see, CH2 plus. Now methyl shift will take place. 1, 2. Methyl shift will take place. This methyl will move to this. Now once the 1, 2 methyl shift has taken place, 1, 2 methyl shift. Now you will get carbocation like this. Now see, let me take to another page the same thing. This carbocation, let me take to another page. CH3, CH3, CH2, CH3. Now just see, kids, the plus charge adjacent to this and this, they are same, but this is different. This is different. So either I eliminate out proton from here or here, means same. But if I eliminate out proton from here, this one is okay. If I eliminate out from here, you will get CH3, C, CH3, double bond CH, CH3. Now which one is Setchip, which one is Hofmann? How to find it out? See, kids, how to find it out? This is double bonded, double bonded. So how many alkyl groups are there? One alkyl group, one alkyl group, one more alkyl group. So this is being tri-substituted. Now if I talk about here the double bond, if you see the double bond is over here. Now how much substituted it is, kids? It is one substitution, di-substituted. So which one is more substituted? Definitely that one is more substituted, tri-substituted. So this is your Setchip product. And this is your major product, kids, major. And this is one is your Hofmann product. This one is your minor. I hope you got it. Now let me tell you, kids, the ring expansion. The most important and toughest question will be asked from ring expansion. How many of you are ready for ring expansion, kids? Thank you, Sahana. Wow, very good thought process. Really, kids, such type of kids only are going to give the rank, not everyone, kids. Wow. South Sea, Herobrine. Wow, kids, wow. Kids, I hope that everyone is able to understand. Now I am going to tell you the ring expansion so that everyone can understand the things, kids. Thank you, Jitu. Thank you, Madhumita. Very good, kids. Very good. Now see, kids. See to it, everyone. The ring expansion, let me tell you the ring expansion. See kids, whenever you are provided with such type of ring, they have given question like this: CHBr CH3 KOH alcoholic heat. Oh, this is the E2 reaction. So simply this is the E2 reaction take place in single step. No ring expansion. This is alpha, this is beta, this is beta. So two types of product will get formed. This one will be major, that one will be minor. Now, if I treat it with weak base like ethyl alcohol, aqueous, heat, so carbocation, water will come, take away this bromide, will get positive charge. Now remember that, my dear students, this is the ring of 5 carbons, 5 carbon ring, the 6 carbon ring, then 5 carbon ring, then 7 carbon ring. This is the stability of rings. Stability of ring. Remember this. 5 carbon ring will try to become 6 carbon because this is more stable. 6 carbon ring is being more stable. Now see how the ring expansion will take place. This lower carbon will withdraw electron like this and will get negative charge. The upper carbon will get partial positive charge. Now it will break this bond. Let's see what is going to happen after breaking this bond, kids. You will get negative charge at this carbon, you will get plus charge at this carbon. Already the plus charge is there. Now see the electron triangle, it has broken this bond. See kids, already this bond has been broken, and which bond is going to get formed? This is the new bond which is going to get formed, kids. Can you see? This is the new bond. It is the electron triangle. Can you see? Now this charge is going to develop partial positive charge, and this partial charge is going to diminish. Now the ring expansion is going to take place. This bond is simultaneously breaking and making a bond, my dear friends. Now see, the bonding has taken place like this, and new bond is formed over here. This is the newly bond formed, newly bond baby like that, newly formed bond. And see, it is CH3 and this is the positive charge. Either you can write it like this or it could be written like this also, kids. See, you can write it like this, well-known 6-membered ring, and the plus charge at this place and CH3 at this place. Now my dear students, see, it is 6-membered ring. That was 5-membered ring, kids. 5-membered ring. It is 6-membered, more stable, but it is in need of the hydride shift. It is saying, hey hydrogen, please get shifted. This hydrogen will shift to this place. Now you will see the most stable carbocation like this. Now it will form two types of products. One hydrogen will go from here, or this, they mean same. So you will get two types of products. One adds the ZJ product. Remember that this will be your answer. AIMS, number of times they have asked this question. This is major, this is ZJ product. I hope you got it. This is minor, this is Hofmann product, kids. This is Hofmann product, Hofmann. Kids, got it? Do let me know. Let me check it out in the chat section. At 10, I will give you one break, kids. Wow, Alia. Alia is appreciating South Sea. That's really great. Kids, I have tried my level best to tell you the ring expansion and the toughest question you can solve, kids. I hope that you got it. I hope that everyone is able. South Sea is really very good student, kids. If you don't know South Sea is very good student. Baba, one question please, okay? Whatever you demand, I will give, kids. Baba is yours. Baba is working for your rank. It's always Madhumita. Very good. Now see, kids. Let me give you one question, kids. See to it. Now see. If in the examination they are giving you this question, CH2 Br, CH2Br, they can give its name also, kids. It is known as ethylene bromide. So remember, its general name is ethylene bromide. KOH, alcoholic. Heat, A, NaNH2, heat, B. What is B, kids? What's B? That's a question. Find out B. Find out B, kids. See, kids, how great kids are. Sahana, Sausi, Madhumita. Fantastic, kids. You are helping this society. Almighty God is really going to help you a lot, kids. God is with you, kids. Study is very good. I will tell you each and everything, kids, but you have to remain with me. Don't be with less energy. You have to show your energy. Baba will always work with you, kids. Baba is always with you, kids. Alkyne, very good. Mahima Shri, your answer is absolutely correct. Your answer is absolutely correct. Now see, kids, how to find out. See, kids, the answer to this question. CH, and let me write down one H over here, one bromine at this place, C, Br and H at this place. Now see, kids, Na. Na will take this bromide. Na will take this bromide. Two bromides will go along with Na. Now NH2 negative will take. Now once bromide is going, it will get plus charge. It will get plus charge. Now once NH2 negative is coming, it will take away this proton. It will get a negative charge. NH2 negative will take away this proton. It will get proton negative charge. Just see, two negative and positive, they will form a bond. First you will get vinyl bromide, CH2CH Br. Its name is vinyl bromide, kids. Now you will get acetylene. Its name is acetylene. Remember that acetylene is general name. Acetylene is general name. Its IUPAC name is ethine. Ethine is its IUPAC name. I hope that everyone, it's clear to each and everyone. Now my dear friends, the same question if they are going to ask, let me give you mind map for this, because very important thing, stereochemistry. Just see. But before giving you the question, this question, see, $1 million question, kids, $1 million question. If I give you this question, the question is CH3, CHBr, CHBr, CH3. Now see, this on reaction with KOH alcoholic. But let me tell you one reaction first, then I will tell you this one. 2 Br are there. The reaction, let me tell you the reaction first. Let me tell you that reaction. Kids, this reaction CH2Br, if I react it with, this is vicinal halide, till now we have seen that dehydrohalogenation. Till now whatever we have studied, that was dehydrohalogenation. Till now whatever we have studied, that was what? Till now whatever we have studied, this was dehydrohalogenation. Kids, are you getting my point? Till now whatever we have studied, that was what? That was dehydrohalogenation. That was dehydrohalogenation. What do you mean by dehydrohalogenation? That was dehydrohalogenation. That means loss of hydrogen and halogen. That was loss of HX, dehydrohalogenation. Now kids, whatever we are going to study here, vicinal halide, this type, if I react it with either zinc plus heat or NAI dry acetone, this type of reaction will be known as dehalogenation. Remember that first of all, what I am telling you, this type of reaction will be known as dehalogenation. Are you getting my point, kids? Dehalogenation, and directly I will get CH2 double bond CH2 plus Br2 will go with zinc, Zn Br2, and this reaction follows anti-elimination. Remember that. This reaction follows which mechanism? Anti-elimination. Very, very tough questions will come from here, kids. And dear students, the same alkene, if it is being added with the Br2 and carbon tetrachloride, it will show addition, and that is also anti-addition reaction. Anti-addition reaction. Now what do you mean by anti-addition reaction and anti-elimination? I will tell you both, kids, with the whole mechanism. I will tell you the whole mechanism. But kids, first of all, you have to understand one thing, kids, the trick. I will tell you the trick before the break, dinner break, and that trick I will let you know after the break. Is it okay? Is it okay? If yes, show me green hearts. I will tell you the mnemonic before the break, and the complete explanation I will tell you after the break. Is it okay, kids? If yes, show me green hearts. The trick is kids, Baba HSP's trick. Remember that TAM, Tushar, Kar, CSM. Everyone just remember this trick. Then I will explain each and everything. TAM, Tushar, Kar, CSM. What do you mean T? What is the meaning of T? T stands for trans, A for anti, addition or elimination, M for meso, S for syn, R for racemic mixture, A for anti-addition, once again, C for cis, S once again for syn, M for meso, and meso is valid only for symmetry, if symmetry is there. If symmetry along with chiral carbon, if symmetry along with chiral carbon, Let me give you the table of this, then I will explain this in detail after the break. Kids, are you ready? Let me give you the mind map of it. Kids, let me give you the mind map of it, and then I will explain after the break. I will explain it after the break, kids. Is it okay? First of all, do let me know. Show me green hearts along with fire. I will take just 5 minutes. Jitu is saying, I understand everything, Baba. Wow, great. Then I will explain in detail after the break, kids. Show me green hearts. Let me give you the table. Wow, kids, wow. Okay. Jyoti Jain Kushga, wow, welcome. Jyoti Jain Kushga, welcome. Now see, kids. This memory chart, this mind map will cover maximum of the reactions. Just see the mind map. This mind map will cover maximum of the reactions. Just see, kids. Just see. Calcium carbide CaC2 on reaction with water. How it will react? See, calcium carbide like this, Ca ionic bond, carbon, triple bond carbon, like this, and it will react with water, kids. It will react with water. H, OH, H, OH. Now it will form acetylene. Just see, it will form acetylene, and that will form calcium hydroxide. So what you will get? You will get acetylene, CH, triple bond CH, and calcium hydroxide will eliminate out. Now this acetylene is having 2 acidic hydrogens. 2 acidic hydrogen atoms. Now it is allowed to react with sodium. Sodium will release hydrogen gas, 2 sodium. So what you will get? C triple bond C Na, Na. Name is disodium acetylide. Disodium acetylide. Remember that, disodium acetylide. Negative, negative, positive, positive. Now it is reacted with methyl chloride. It's being reacted with methyl chloride, 2 equivalents of methyl chloride. Methyl chloride gets 2 equivalents of methyl chloride. Then sodium chloride will eliminate out. Sodium chloride will eliminate out. What you will get, kids? You will get CH3, C triple bond C, CH3. This you know, alkyne. Now there are 2 ways goes from here, kids. 2 ways. One way goes over here. One another way goes over this side. Just see, kids, 2 ways from here. 2 ways. One is a Lindlar's catalyst. That day also I have told you Lindlar's catalyst. What is a Lindlar's catalyst, kids? If I talk about NCERT, in NCERT it is only written H2 palladium carbon. Only this much is given in NCERT. If I talk about NCERT, kids, only this much is mentioned about Lindlar's catalyst in NCERT. So remember that in NCERT only this much is written according to NCERT. But if hi-fi books, they are going to give you this one. They will write H2PD barium sulfate charcoal boiling xylene quinoline. This much they can give you, kids. Both will work same. They will give cis alkene. What they will give you, kids? Cis alkene. You will get CH3 CH double bond CH CH3. Remember that, cis alkene, cis. Now if you do the reaction with, gets sodium liquid ammonia, this is known as Birch reduction. Birch reduction, kids, Birch reduction. You will get trans alkene. Remember that, you will get trans alkene. Now the story will start. Now the story will start, kids. Trans, this is not trans. Trans alkene. You will get trans alkene, kids. Now cis alkene, trans alkene. Now remember that, my dear students. Now the story starts. This one. Are you ready? Do you remember TAM, Tushar, Kar, CSM? Everyone say TAM, Tushar, Kar, CSM. Then only I will tell you the mind map will work. TAM, Tushar, TAN, Tushar, Kar, CSM. TAN, Tushar, Kar, CSM. You have to complete it once I am asking it. TAM, Tushar, Kar, CSM. Everyone say TAM, Tushar, Kar, CSM. TAM, Tushar, Kar, CSM. TAM, Tushar, Kar, CSM. No problem, no problem. Those who are late, no problem. But say everyone TAM, Tushar, Kar, CSM. Now see. Remember that whenever you add bromine on this, whenever you are going to add bromine on this, remember this point, kids, what I am saying. Whenever you are going to add bromine in this, bromine will do what type of attack? Bromine will always do anti-addition. Br2 will always do anti-addition. Anti-addition, always anti-addition, anti. So C, where it has gone? Anti. So C, just C, A, complete it. What you will get? Ca, complete it. Ca, what will come? Ca, fill in the blanks. What will come? Ca. Everyone, if you're not responding, what I will do? C-A-R. R, that means car. So you will get racemic mixture, kids. What you will get? You will get racemic mixture. Those who understand what you mean by racemic mixture, the stereochemistry, optical isomerism, those who understand, they can only understand what you mean by racemic mixture, kids. So one Br will on be this side, one Br on this side, one hydrogen, one methyl, one Br, the mirror image, enantiomer of it, enantiomeric pair, CH3. So this is dextro and levo racemic mixture, a pair of enantiomers. Enantiomeric pair, kids. I taught you this. Enantiomeric pair. Now, kids, if I do the reaction with the zinc, if you react it with the zinc, if you react this racemic mixture with the zinc, what you will get, kids? If you react this racemic mixture with the zinc and heat, Zn heat, it will cause anti-elimination. Now complete it, gets racemic, R, take R of racemic, R, A. So complete it, Ra, C, you once again you will get cis alkene. It's clear to all of you? Is it clear? Now the same thing if I have done with this one, Br2, CCl4, it will do anti-addition. Anti-addition gets Ta, just complete Ta, fill in the blanks. Everyone say in the chat section Ta. I want to see, kids, you are participating or not. You are participating or not, kids? TA. What should I write? TA. TA, kids. Do let me know TA. Everyone just do let me know TA. What should I write? Thank you, kids. TA. TAM. Meso. TAM. What do you mean by meso? Those who know meso, they can understand, kids. Meso, the meaning of meso is that I will get one bromine at this place, one bromine at this place, two chiral carbons gets two chiral carbons, CH3, two chiral carbons. Along with two chiral carbons, I'm having the plane of symmetry. The plane of symmetry, that's why it is known as meso, kids. That's why it is known as meso. Meso, kids. That's why it is known as meso. Along with chiral carbons, it is having plane of symmetry. It is known as meso, kids. Meso. Now, if I react this meso with the zinc, if I react it with the zinc, then anti-elimination, zinc heat, anti-elimination, I will get this one. Now, kids, how many of you are able to understand? How many of you got it, kids? How many of you are able to understand this one, kids? Do let me know. How many of you got it? Kids, do let me know how many of you got it. Everyone just do let me know. Everyone ingeva and do let me know, kids. The idiyappam things has become, idiyappam murku has become nalla irku, arpu dham, romba sulbham. Those who are thinking chemistry pedicare customer, I would like to say LL, it's romba sulbham, kids. Now, Now kids, let me tell you a little bit more. Let me add a little bit more to this. Let me add a little bit, just a little bit more to this, kids. See that I have told you that this is your butane. This is your butane. How I have converted into butene? How I have converted it into butene? Do let me know. That Lindelar's catalyst. One was Lindelar's catalyst. That has given you what, kids? Do let me know. That has given you cis alkene. That has provided you what? Cis alkene, right? Am I right, kids? And sodium liquid ammonia, that has provided you what, kids? That has provided you transalkene. Now kids, just remember how many things are doing syn addition. How many people are doing syn addition? Then only you can complete this chart. Let me tell you kids, remember that if I talk about, I have already told you bromine, Br2CCl4, just remember what it is doing. It is doing anti-addition. Anti-addition, you have to cram it. Just cram it, kids. Cram it. I will tell you the reason after the break. Cram it. If I say D2 nickel, that day I have told you it is doing syn addition. Remember that it will do syn addition. I told you in alkane. Now if I say that I am having KMnO4, cold dilute alkaline KMnO4, kids, it is known as Bayer's reagent. It is known as Bayer's reagent. Bayer's reagent, kids. Remember that Bayer's reagent. In old days, people were using it as a medicine. Now, what it will do? It will do syn addition. It will do syn addition. Just remember that will do syn addition. This will do syn addition. And how? It will add up to OH. Bayer's reagent. If I talk about Bayer's reagent, it will add 2OH on the double bond, means adjacent. Now kids, if you remember this, then only I will tell you the TAM Tusharkar CSM. TAM, how the life will become easy. TAM Tusharkar CSM. Then I will tell you how the magic will work, kids. I will show you the magic. First of all, everyone, just to let me know you are ready. This much you have kept in your brain. Br2CCl4 will always do anti-addition, anti-elimination. Whatever it is going to do, always anti-addition, anti-elimination. These will always do syn addition. These will always do syn addition, kids. They will always do syn addition, kids. This much it is clear in your brain, then only I can complete that table, kids. If this is going to your brain, do let me know, kids. This is gone to your brain, kids. Now, let me complete this table, kids. This table. This is your cis alkene. Why it is cis alkene? Because both the hydrogens are on same side. The hydrogens are on same side. That's why it is cis. The hydrogens are on opposite side. Trans. Now, kids, already I have written what? That Br2 is going to add on this. You know Br2. Tell me anti or syn. Complete. No one will tell you in exam. Br2 anti or cis. Tell me in the chat section. Anti or cis. Anti. Now try to complete. Ca. Ca, already I taught you, CAR, so mixture will be racemic. This already I taught you. Same here, Br2 will do anti, CCl4 anti. Now already I taught you trans anti, TAM, meso, this already I taught you. Now what I am trying to tell you, kids, see what I am trying to tell you, just see, kids. Now if I react it with Bayer's reagent, just see Bayer's reagent, kids, Bayer's reagent, just see, kids, Bayer's reagent. Now see, now Bayer's reagent will do syn or anti. Do let me know in the chat section, syn addition or anti addition. Bayer's reagent, what I have told you, Bayer's reagent will do syn addition, syn. So syn, so Bayer's reagent, whenever I write Bayer's reagent, you should have to think about syn. Automatically this should come to your brain. C, S, C, this is C, then S, complete. CS, complete. Let me see in the chat section you are completing it or not. Get CS, completed, kids. CS. Let me check it out whether you are able to understand or not. CS. No one is. Namita, Madhu, complete, kids, completed. CS. What should I write? CS. What should I write, kids? Not CSR. Oh my god, who is writing CSR? M, meso, CSM. See, one people has written CSR, CSM or MSC, opposite MSC, CSM, MSC, race, roast, mat. You can just go like this, MSC, race, roast, mat. Now see, kids, CSM, meso. Then how I will write meso, kids? See how I will write meso. Just see to it. Chiral carbon, OH, H, CH3, two chiral carbons along with plane of symmetry. I hope that you got it, kids. Two chiral carbons along with plane of symmetry. Can you see the plane of symmetry? Can you watch the plane of symmetry, kids? Do let me know. This is meso, and this is the best question of the AIMS, IIT, NEET, whatever you talk about. This is the best question, kids. The best question. Just see. It is having plane of symmetry. Plane of symmetry is present, and that's why it is meso. Now if I have reacted with D2 nickel, just see, if I would have reacted it with D2 nickel, what it will do? Syn or trans, D2 nickel, syn addition. Once again I will get CSM, meso, gets meso, D, H, CH3, meso. Now if I have reacted with Bayer's reagent, now try to complete it, kids. Bayer's reagent, T, but this will do syn addition, syn, TSR, racemic, so I will get this product, kids, racemic, OH, CH3, and the mirror image of this OH, CH3, racemic mixture. Kids, now this is completed, kids. The chart, how many of you are liking it, kids? Now I will give you break, and sorry a little bit. Okay, little bit I got late in giving the break, kids. Kids, now it's a break time. Break. Let's meet at 11:15. Dinner break. Kids, I will tell you alkene and alkyne in detail. Thank you everyone, thank you. So 11. Oh, so let's meet at 11. Okay, let's meet at 11, kids, right? Okay, 11:15. Okay, it's a dinner break, but 11:15 it's too much, I think. Let's meet at 11. Okay, kids. 11. Let's meet at 11, kids. Everyone is writing 11:15. Okay, kids, but it's too late, so no, it's not. Let's meet at 11. Okay, kids. Okay, kids. Okay. Kids, are you there? Everyone? I want to see some fire. So symbol that you are ready with full on Josh, kids. Yes, yes, yes. So, till now what we have done, let me tell you, kids. We were dealing with preparation of alkene, preparation of alkene. So for what we have done, kids, we have completed dehydrohalogenation, dehydrohalogenation got completed, kids. Dehalogenation also got completed. Now, what's ahead? What's ahead, kids? Dehydration. We will deal with dehydration, that is loss of water to prepare alkene. Dehydration. Let me tell you, my dear friends, here we have eliminated out HX, loss of HX. Here we have done loss of X2, and here we will do loss of water. After doing all these three things, I will tell you ozonolysis. Ozonolysis. Wow, kids, so active. Baba is so happy with your this much of great energy level. Really feeling good. Now after this, I will tell you ozonolysis. These many preparations, and after this, I will tell you the chemical properties. The Markovnikov's rule, oxymercuration, demercuration, brown hydroboration. Kids, you have to show energy level, right? Baba is so active. Can you see? Let me check in the chat section that everyone is with full on Josh. Wow, kids, really I'm happy. Sahana, Madhumita, Anandita, Johnny, Praveen, Greeno, Johnny, okay, kids. Wow, fantastic. Baba is so happy. Really. Now, kids, the sequence I have told you, the preparation, the first two we have already completed. Yeah, Stella, thank you. Mahalakshmi, thank you. Sure Money, thank you. Saucy, organic Romba Silvam, wow. Saucy, thanks. Johnny is active. Kishore Money is active. Madhumita, everyone gets okay. Now, let's deal with dehydration. Let's go, kids. Whenever somebody is teaching you in detail, time is required. To teach in detail, teaching in detail requires time, kids. Really, it requires time. Without time, nothing can happen, kids. We need time to go in detail. Always, it needs patience. It needs a lot of things, kids. If we want to go in detail, there is need of number of things, kids. Okay, so I have removed my shoes. Now I can teach comfortably, kids. Dehydration. Just think about dehydration, kids. What's dehydration? Let's see, kids. Very bad. Dehydration. There are two types of dehydrations, E2 and E1 kids. E2, that is non-acidic dehydration, non-acidic. And second is one is acidic hydration, E1. Acidic dehydration reaction, right kids? Everyone? Without shifting, here shifting may take place, right kids? Everyone, just to let me know. E2 and E1. Now what are the reagents? Let me tell you the reagents which are responsible for it. If I talk about non-acidic, so alumina, Al2O3, alumina plus heat, or you can say thorium oxide, THO2 plus heat, and here concentrated H2SO4 is the reagent, or you can say concentrated H3PO4 is the reagent, or you can say P4O10 aqueous is the reagent. These are the two types of dehydration kits. Okay, so ready everyone? Are you ready? Let's deal with first non-acidic dehydration. Single step mechanism, single step kits. If I write down like this kits, 5-membered ring, it can't do expansion. No ring expansion can take place. Concerted mechanism will take place. What is concerted mechanism kits? Single step. Single step means what? If I write down this OH, this is alpha carbon, this is beta. Now from beta hydrogen will go and from alpha OH will go like this. OH negative will go and this proton will go. They will form a bond like this. Now this will develop plus charge and this will develop negative, and negative positive will form a bond. So this bonding will take place, my dear friends. This will be the product. No rearrangement. Now if I have given you a reactant like this, this is OH, you can see this is the alpha carbon. Here you can see there is no beta, so no elimination. If I write down Al2O3, heat, no reaction. Why no reaction kids? Why no reaction? No beta hydrogen. As no beta hydrogen atom. Now kids, if the same reaction, if we carry out in acidic, that is acidic dehydration, if the same reaction would have been carried out, that's if I talk about acidic dehydration, then see to it kids. What should be the answer? What answer you are going to get? If I talk about acidic dehydration, same reaction kids. Same reactant I am taking. Now see, concentrated H2SO4 has been added to this solution. Now what? This will react first, this will react first. This is strong acid. Strong acid kids. What do you mean by strong acid? The strong acid will donate its proton. Once the proton has been donated, this proton will attack on the lone pair. Ta-ta-da! I'm coming. Inge ba. Chung. Attack. Now remember what is going to get formed. Oxonium ion. Low. Ta-ta-da! O positive H2. Ting. Oxonium ion. What is the name, kids? Oxonium ion. What do you call it? Everyone say oxonium ion. Now this oxygen will say, I can't tolerate this positive charge. I can't tolerate this positive charge. So what we will say? We have to eliminate. The oxygen is saying, I can't tolerate this positive charge. We will say, oh, I have to remove water. We have to remove water. Water will get eliminated. So water will get eliminated and you will get ring like this. Now once this carbocation is formed, just think about a ring expansion. This will break its bond from here. The bond will get broken up. This will get negative charge, positive charge, and this is already being positive. So bond has been broken from this place. It has broken from this place, so it will form at new place. This is new bond formation. This is new bond formation, new bond formation. So its charge will decrease. They will form a bond like this. You can write it like this, 6-membered ring. Now positive charge. Now from the neighborhood, proton will eliminate out. Once the proton will eliminate out, negative and negative positive, hence in this way their happy ending, marriage got completed. Major product kits, major product, 6-membered ring. I hope that everyone got it. Everyone got it. Just to let me know in the chat section you got it or not. Everyone, just to let me know, kids. Everyone, my dear students, do let me know you got it or not. I want to see in the chat section that everyone, yeah, what I can see, yes. Hey everyone, Astor, Charm, hooray, Sahana, yes. Now, each and everything got completed. Now, let me come to the chemical properties, kids. I've told you the preparation of alkene. In this way, the alkene is going to get formed. Now, let me come to the chemical properties. Yay, yay, yay. So, alkenes, chemical properties. Hip, hip, hooray. We are going to deal with alkene, yababa, alkenes, chemical reactions. Are you ready, kids? Chemical reactions. In the chemical reactions, kids, what I am going to tell you: Vanna, Randa, Mono, Nale. Let's see. What Baba is going to tell you? I will tell you, kids. Number 1, I will tell you hydrohalogenation. Hydrohalogenation, I will tell you hydrohalogenation. What do you mean by hydrohalogenation? Addition of HX. Addition of HX. Then I will let you know, gets second, that is what? Addition of X2. Just reverse what we have done. Then I will tell you addition of water. Whatever we have eliminated out, we will add. And water, I will tell you OM-DM reaction. I will tell you HBO reaction. Here addition of HX, I will tell you anti-Markovnikov's rule. Markovnikov's, anti-Markovnikov's, I will let you know. These things I will tell you, kids. And then miscellaneous, okay? And then you can say ozonolysis. Ozonolysis. I will tell you ozonolysis. Right, kids? Everyone? Are you ready? Is everyone ready? Everyone ready? Okay, let me start, kids. First, I will tell you the general mechanism so that you can solve every question. General mechanism. This is most important. Focus over here, kids. This holds a hell lot of weightage. Very, very important. And this way you must have never studied, kids. Very, very important. Very, very important. Now see, kids. First of all, let me see, kids. At one place I think I have written ozonolysis. What is this? Acidic dehydration. Okay, in preparation of alkene, ozonolysis will not be there because this will come in the chemical properties. Okay, it will come in the chemical properties. That's why I was thinking it's not over here, right, kids? Now, kids, journal mechanism, very, very important. See, if I write down any alkene like this, RCH double bond CH2, and this is an example of nucleophile. See, just kids, RCH double bond CH2. This is having pi bond, pi electrons, so it is an example of nucleophile. Remember that? Nucleophile. What I am writing? Simple alkenes, simple alkadines, benzene generally, they are simple alkynes, they are example of nucleophile. Remember that these are example of nucleophile, and that's why the first attack will be done by ENU. ENU is electrophile and nucleophile combo, and electrophile will attack first. That's why it is known as electrophilic addition reaction. The first attack will be done by electrophile, and that's why it is known as EAR. Remember that EAR, what is the full form of EAR? Electrophilic addition reaction. Addition reaction. Electrophilic addition reaction. Are you getting my point? Electrophile will come and attack on this. Gachak. Now, kids, once the electrophile is going to attack, it will attack in such a way to give more stable carbocation. It will attack in such a way to give more stable carbocation. Are you getting my point, kids? Everyone, just to let me know in the chat section. Electrophile will attack in such a way to give more stable carbocation, kids. Kids, do let me know. Electrophile will attack in such a way to give more stable carbocation, to give more stable carbocation. Now, my dear students, whether this carbocation will get formed or not, that depends on E. Whether it will be formed like this or this will get formed. This is the most important point. It's $1,000,000 question, that whether that carbocation is going to form or the cyclic three-membered intermediate will form. Known classical carbocation, that is carbocation. This is carbocation, kids, and this is three-membered unstable ring, highly unstable ring, kids, known as non-classical carbocation, kids. Now, how to decide? How to decide which will get formed? That will get formed or this will get formed? Kids, this is $1,000,000 question, $1,000,000 question. Now, my dear students, if this is getting formed, rearrangement may take place. Rearrangement may take place. May take place. And this is getting formed, no rearrangement case, no rearrangement. No rearrangement. Markovnikov's rule is always valid over here. What is Markovnikov's rule? I will let you know. Markovnikov's rule will always be applicable. Now, this case or that case, the carbocation formation case or known classical carbocation case formation, who will decide? Who will decide? If you are able to answer it, if you are able to get it, then each and everything will be sorted out, each and everything clearly you can understand. Now see kids, case number 1, I would like to say always go for this case, case number 1, always see this case, case number 1, that if E is mercury, remember that if E is mercury or E is having at least one lone pair, at least one lone pair, either of these two. If E is having at least one lone pair or E is mercury, remember that my dear students, either E is mercury or having at least one lone pair, then three-membered ring, then three-membered ring formation. No rearrangement case, no rearrangement. Kids, remember that, no rearrangement case. And always anti-attack. Why anti-attack? I will let you know. Always anti-attack. So this is case number 1. Always remember this case, kids. Now, case number 2, very simple. Case number 2, if no case number 1, then case number 2. It's very simple. If E is not mercury or doesn't have lone pair, then kids, then carbocation formation case. Formation will take place. Rearrangement may take place. Now kids, now you have to apply your brain. You have to answer my questions. Are you ready, kids? Are you ready? You have to apply your brain and you have to answer my questions. See, kids, if I say this is R CH double bond CH2, and if I add HX, what you will say, kids? Do let me know. Which case? Carbocation formation case or three-membered ring? Non-classical or carbocation formation case? See, compare. This is E nu. It's E, that's nu. And E is H. Do you think H is having any lone pair? No. So it is carbocation formation case. Carbocation formation case. Rearrangement may take place. Definitely rearrangement may take place. Just apply your brain, kids. Now second, if I say addition of X2, what you will say, kids? Addition of X2, X, definitely X is having lone pair. Either I talk about this X. Now compare with E nu. E nu, this is E, that is nu. So the electrophile will be having lone pair. So non-classical carbon ion, non-classical carbocation, non-classical. carbocation means no rearrangement case, no rearrangement. Now third, if I say addition of HOX, hypoalous acid, H delta positive, okay, OH delta negative, X delta positive, where HOX can be HOCl, HOBr, HOI, but can't be HOF. Why? HOF is not stable at room temperature, otherwise fluorine would have negative and this will have positive, but does not exist, not stable at room temperature, not stable at room temperature, kids. So definitely this is also having X, so same case, non-classical, so no rearrangement, and in both these two cases anti-addition will take place. Anti-addition. Why anti-addition? I will tell you, kids. Till now is it okay, kids? Now these many things I have told you. Now addition of water. Now comes the addition of water. Acidic, first is acidic dehydration. Rearrangement may take place. Rearrangement may take place. B is OMDM. Markovnikov rule will be followed, no rearrangement, because mercury will be used, I will let you know. C is HBO reaction, anti-Markovnikov addition, no rearrangement. These many kids I have written at one place. Now let me move one by one. Till now is it okay, kids? Your answers I can see, kids. Don't ask about the timings, kids. Kids, Baba is giving you content, so don't think about the session timing and this and that, kids. Right now focus. Baba is giving you the content, the best content. No one can give you this content anywhere in the world. Okay, so let me move, kids. Now let me tell you Markovnikov's rule. At each and everything, let me tell you. Kids, see. First, let me tell you the addition of HX. Then, right now I am not interested in telling you Markovnikov's rule, because in this rearrangement can take place. So, just focus. Just focus. If I give you alkene like this, then what do you think, kids? What do you think? HCl, where HCl will attack? H plus, first attack will be shown by H plus. H plus will attack in such a way to give more stable carbocation. This side carbocation is more stable, so it will attack at that place to give more stable carbocation. This carbocation is more stable, so H will attack at this place. Am I right, kids? Now the carbocation has been formed. Remember that once the carbocation is formed, think about rearrangement. And rearrangement, I have told you earlier that 1,2 hydride shift will take place. 1,2 hydride shift, kids. Right? Now what you will get? Another carbocation like this. Now what do you think? Which carbocation is being more stable? What do you think, kids? Which carbocation is more stable? If I say this is X carbocation, this is Y carbocation, so the Y carbocation is stabilized by resonance. Just see, it is doing resonance with this benzene. So SBr is stabilized by resonance. So chloride will come and attack over here. Now my dear students, those who have crammed what? The Markovnikov's rule, they will definitely get failed. Why they will get failed? Because the shifting has taken place. Because of the shifting has taken place, and those who are cramming it, they will get failed. Now positive negative, because the attack will be from above the plane and below the plane. This is pure so dextrolivoracemic mixture. And this is the major product kits. If you attack chloride at this place, this is going to be the minor product. This will be your minor product kits. Got it? So kids, this addition of Hx, you got it. Now let me tell you addition of X2. There I will explain anti-addition, right? Anti-addition. Just see to it. I hope this point is clear to each and everyone. Now addition of X2. Addition of X2 kids. Okay, ready? Is everyone ready, kids? Is everyone ready, kids? Addition of X2. I want to see that everyone is ready, kids. Full on Josh. Let me see in the chat section with full on Josh, kids. Wow, Johnny, that's really fantastic. ABCD, Harry, Johnny, Anandita, fantastic, kids. Now show me green hearts if you're ready, kids. Full on Josh. If you are with full on Josh, kids. Now see, kids, what I was telling you, addition of X2. Addition of X2, just see. Why we say it follow anti-addition, just see to it, kids. If I give you this reactant, everyone in the examination will think about ring expansion. Now let's see what you will say, kids. If they are giving you addition of Br2. Now Br is electrophile and Br is nucleophile. Can you see, kids? Br is electrophile and Br is nucleophile. So one Br will come and attack over here, but Br is having lone pair, so it will form this type of intermediate. Just see, kids. Very interesting intermediate. Very interesting intermediate, kids. And this is known as bromonium ion. If plus charge is on carbon, we say carbonium ion. Oxygen, we say oxonium ion. Bromine, the plus charge, bromonium ion, we will say bromonium ion. This is bromonium ion, my dear students. Bro, Anna bro. Bromonium ion, kids. Now it will it is non-classical carbocation. Non-classical carbocation, kids. Now, kids, it has taken, or you can say it was having lone pair, it has helped this carbon. Because it was having lone pair, first it will come over here, then with the help of lone pair it will donate this carbon, means a lone pair it will donate to this carbon, and the charge of carbon will decrease. And how much it will decrease, kids? Let me tell you. Suppose you are having 20 rupees, you You are having enough money to buy samosa, but you are not having that much money to buy pizza or chicken biryani. So you are having less money. You are not having that much of money so that you can afford for pizza or chicken biryani, but you are having that much of money that you can attract samosa and you can eat samosa. So it is having that much of plus charge so that it can invite nucleophile to come and attack on it, but it is not having enough positive charge to do the rearrangement. It is not having that much of charge. Let me tell you kids, this carbon is having enough charge only to attract whom? Nucleophile, but not that much enough charge, so that it can allow rearrangement to take place. Are you getting my point, kids? Because that bromine acting like bro helped him and decreased the charge. It has decreased the charge, so rearrangement can never take place. And now the another bromine negative cannot attack from the same side. It will come from the opposite side. That's why it is known as anti-addition. So let me draw that positive charge, that ring once again at this place. Just see kids. Now another bromide will come from the opposite side. It cannot come from the same side, and that's why it is known as anti-addition. I hope that everyone now this point is clear. What do you mean by anti-addition? So you will get compound like this. Now kids, those who don't know that in this reaction the rearrangement will not take place and the ring will remain 5-membered only. Otherwise maximum people will get failed at this place, kids. Maximum kids will get failed. Clear? I want to see in the chat section that it is clear to all of you kids. Otherwise those who know what is a ring expansion, they will carry out ring expansion. Stella, Alia, clear kids? Do let me know kids. It's very much clear to each and every one of you. Questions I will give you. Saucy, just wait. Let me teach you. Then I will give you question. First, let me tell you Markovnikov's rule. Then I will give you. Okay, Saucy, I will give you. Definitely. Now, after this, addition of HOX. Let's see addition of HOX. What is HOX? See what is HOX. If I say X2 plus water, this is in equilibrium with HOX. Whatever is given, just find it out. X delta positive, OH negative, because halogen with respect to oxygen is more electropositive. Only fluorine is more electronegative than oxygen, but that at room temperature is not stable. So HOF we will not take because not stable at room temperature. So remember this point to be noted, my lord. Now, this is known as hypohalous acid. Hypohalous acid. Now, if you see kids, once again I would like to say the same ring if I take and same reaction if I do HOCl. Now see, this is the negative part. Directly you can say, you can do in two ways. First, the mechanism, let's see. The mechanism says it will attack over here and later on that will attack at this place, but not from the same side. Anti-addition, it will attack from here, it will attack from here. Anti-addition, so the product will be CH2 and OH. What I have written, kids? I think I have written wrongly. Just see, this is delta negative and that is delta positive, right kids? Delta negative, delta positive. So the electrophile will attack at that place, ClOH, right? This is the mechanism. This is the product. Same thing if I carry out with the help of Markovnikov's rule. Remember that Markovnikov's rule is valid only when the rearrangement does not take place. Now see, the same thing you will get with the help of Markovnikov's rule. See. Markovnikov's rule. Oh my God, what is this? What he has done? So let me write down myself, from myself side only, Markovnikov's rule. This rule says negative part of the reagent goes to that double bonded carbon which has less number of hydrogen atoms, but for this, provided that reactant and reagent must be unsymmetrical. Reactant and reagent must be unsymmetrical. For example, if I write down the same thing, kids, which I have told you, just see, if I talk about this alkene, this is unsymmetrical, that side something else, this side something else. Now if I do the same question with the help of Markovnikov's rule, HOCl, can you see, kids, can you see HOCl? Now what I will write, this Cl positive, this O negative, that negative part of the reagent goes to that double bonded carbon which has less number of hydrogen. It is having one hydrogen, it is having two hydrogen, so it will come over here, that will go over there. Same thing, see. We have done with the mechanism, we have got this product. With the Markovnikov's rule also we are getting the same product. But remember that this is valid only when there is no rearrangement kids. If rearrangement has taken place, this rule will get failed. So Markovnikov's rule is not that important because it is valid only when there is no rearrangement. Kids, are you getting my point? Just to let me know in the chat section. Kids, it's really requires lot of patience. Kids, do let me know you are getting it or not. Everyone, just do let me know. Everyone. Thank you, Sausi. Thank you. Now today I will tell you the TAM, Tushar card, CSM. I have told you I will explain that also. Let's see, kids. Let me explain that one also, kids. Just see, if I say the stereochemistry, Baba is going to explain about the stereochemistry. Let me explain the stereochemistry. Which stereochemistry I am talking about? Let me say CAR. I am going to prove CAR. Do you remember that trick? I have told you the trick. So see, kids, if I say that I have taken C double bond C and I am writing the hydrogen is coming towards yours, okay, methyl is coming towards your side. Hydrogen is going away from you. Methyl is coming towards your side. So I am trying to make cis. Definitely I will make it. Hydrogen is going away from you. Now there are 4 lobes of this pi bond. This is the pi bond. It is forming 4 lobes. 1, 2, 3, 4. Everyone is having this pi bond. Pi bond is moving like this. Right? Now Br2, I am going to attack Br2. See the magic, kids. Today I will show you the magic. Magic is going to happen. See, Br2 is going to attack. Now the first Br plus is having chance to attack on all 4 lobes. Either from upside or downside. It can attack at this place, that place, this place, anywhere. So let me make its attack from upside, okay? If it is doing upside attack, these will come downside. If somebody is putting too much weight on my head, then I will move like this, but my eyes will be pointing towards your side only, na? Or if somebody is going to lift me up, I will go like this, but my eyes will be on, means towards your side only. They will not go back side. They will either go like this or they will come like this. So if bromine carbocation is attacking from upside, these will come down, but this will be pointing towards your side and that will be pointing away from you. Now see what you will get. CH3 as earlier. Hydrogen away from you. Carbon, the methyl will come a little bit downside, but will point towards your side, will keep on pointing towards your side only. Hydrogen will go away from you only, but will come little bit downside. Br will come over here. Now another Br, when it is going to attack, it will come from downside because anti-addition, right? Another bromide will attack from downside, anti-addition. So once it is going to come and attack at this place, they will go up, but this will keep on pointing towards your side and that will keep on pointing away from you. Now see how to draw it. See, CH3 will be towards your side only, but will shift a little bit up. Hydrogen will be away from you, but go a little bit up. Now bromine will come over here. Now this will be like this. This already has decided its orientation, kids. And this bromide will be at this place. Now kids, this is one compound. If this bromide has attacked from downside, then that bromide would have attacked from upside. So we will get its mirror image also, right? Till now I hope everyone is clear. Now see, this alkene was what? Cis. This was cis. This attack is anti. According to our trick, this should be racemic, and this to be racemic, its configuration of chiral carbon should be either RR or SS. If it is RR, then this will be SS. If that is SS, this will be RR. And if it is not like that, then Baba is not a good teacher. Then Baba is not a good teacher. Let me explain, kids. Let me explain. See, if you know RS system, RS configuration, if you know RS configuration, now see, kids, bromine will get number 1. This carbon, this hydrogen, this is away from you, least priority group. Now this carbon is attached with bromine, so this will get number 2, and the arrow will go like this, and this is moving anti-clockwise, and the hydrogen least priority group is away from you, so I will say this is S configuration. Now let's see this carbon. Now let's see this carbon, bromine number 1, and that carbon is attached with bromine, this is attached with hydrogen, so number 2. So arrow is going which direction? This arrow is going anti-clockwise direction. This is also S. So this is SS configuration. So definitely this is going to be RR configuration, and they are enantiomeric pair. So dextro and levo mixture, racemic mixture. Hence proved, kids. Hence proved. I have proved each and everything. Just see, those who have got it for the first time, those who are able to understand it for the first time, do let me know, kids. Tell me, kids. Is it clear to all of you or not? Yes, kids. Madhumita, clear. Vishalni, first time. Those who got it for the first time, do let me know. Very good, kids. Very good. Now let me tell you addition of water. Now let me tell you addition of water, kids. Very good. Very good. Madhu, Namita, everyone. Fantastic, kids. Now addition of water. Let me tell you addition of water. First is acidic hydration. Acidic hydration, kids. Acidic hydration, let's see. Suppose if I write this is benzene CH2 CH double bond CH2, and if I add D2O in presence of H2SO4. Now three type of entities are there. Never cram it, just try to understand. Never cram it, just try to understand what is going to happen. See kids, this is acid. First it will break to give H plus. Now this H plus will attack where? This H plus will come and attack on this bond. Now see, it will attack in such a way to give more stable carbocation over here. So you will get more stable carbocation like this. Now remember that whenever carbocation is formed, what's your duty kids? What's your duty? Whenever carbocation is formed, always think about rearrangement. So 1,2 hydride shift will take place. Once 1,2 hydride shift is taking place, you will get better, more stable carbocation. Now why this carbocation is more stable? Because it is stabilized by resonance. It is nearest to benzene ring. So it is stabilized by resonance. So water will attack on this, but there is D2O, heavy water. So let me write down at this place. So heavy water, D2O will attack and minus D plus will take place. So it will get added at this place. So your answer will be like this. OD will be there kids. This is going to be the major product. This will be the major product kids, right? Now let me tell you oxymercuration demercuration reaction. Oxymercuration demercuration, let's see to it kids. Oxymercuration demercuration, what is going to happen over here? If I say that I have taken this compound remember that mercuric acetate CH3COO whole twice mercury THF water NaBH4 OH negative. Now pure alcohol, because when we talk about alcohol, purity matters a lot. Purity matters a lot. So you will get pure alcohol CH3 according to Markovnikov rule. OH CH3, pure alcohol without any shifting, without any rearrangement. Whenever mercury is there, remember that whenever mercury is there, rearrangement will never take place. I have told you rearrangement will never take place. Never take place, kids. Okay. Now Brown hydroboration reaction. Same alkene, just see CH3. CH double bond CH2. BH3, either BH3 is given or B2H6 is given. THF, H2O, H2O2 OH negative. Now it will follow anti-Markovnikov's addition without rearrangement. So what you will get, kids? Now in alkene only ozonolysis is left, kids. Only ozonolysis is left. Once I tell you ozonolysis, then I will give questions. Wow, kids, how see really good, because I can see number of students, they must have gone for sleep, and those who are sleeping, they are losing their rank, kids. Only few students are left, and these are really good students, kids. I will try to complete it just in 60 minutes or 45 minutes, right? So don't worry, kids. 45 minutes to 50 minutes I will try to complete, kids. Just 45 to 50 minutes, right, kids? Now let me tell you the last chemical property of this alkene, that is ozonolysis. Then I will give you number of questions, kids. I can see very good students are over here. Rest of them, they have gone for taking their sleep, kids. No problem. Ozonolysis, kids. See, ozonolysis. First, let me tell you reductive ozonolysis. Let's see the reductive ozonolysis, kids. R1, R2, you will get ozonide, monoozonide. Unstable monoozonide. Now you have to react it with zinc and water, kids. Zinc and water. Now one oxygen will be kept by that carbon, one oxygen will be kept by this, and the last one will be taken by zinc and it will form ZNO. ZNO will eliminate out like this, and they will get converted R1, CR2, CR3, R4. They will break down, and how they will break it, just see, double bond O, double bond O. So whatever we have done, we can see directly, see kids. O3 short trick, zinc and water, along with sigma break pi, along with sigma break pi, and add oxygen. And if you want to come back, you can come back. I think you have seen what to do, kids. Let me give you some questions. Try it out. I will write down the product after some time, kids. Just you try it out. So what you will see in these three, that all the three were symmetrical, so you will get only one type of product. Remember that when the alkene is symmetrical, you will get product of one type only, right, kids? Are you getting my point? You will get product of one type only. When it is unsymmetrical, when it is being unsymmetrical, you will get more than one type of product. I hope that everyone got it. This one only gets, this much only gets. Everyone got it, kids? Your answer is like this only, kids. Do let me know, kids. Now, by chance, if examiner has given you a question like this, and he is asking what is that compound, what is the IUPAC name of this compound. IUPAC name of this compound, what you will say, kids? Now what you are supposed to do, kids, how will you find out the answer? Just see, bring those two compounds like this, keep in front of each other like this. Now just remove their oxygens. Just remove their oxygens, combine them. Methyl pentane. This is correct, kids? Is this fine? Fantabulous, kids? Everyone got it? Now, each and everything. Now, oxidative ozonolysis. Let's see. Kids, only 30 minutes, not more than that. Don't worry, kids. O3 Now, there is no zinc. Remember that there is no zinc. Only water is there. Now, one oxygen this carbon will keep, one oxygen this carbon will keep, and the next one H2O will take, and H2O will get converted into H2O2. Hydrogen peroxide is being more mild oxidizing agent. Remember that. Now, what he will do? Just see. Now it will attack on these two compounds. H2O2 will attack on these two compounds. And what the effect? Let's see on the next page. Its effects, let's see on the next page. If they are found to be aldehyde, then H2O2 will oxidize them. RCOH will be the answer. Remember that one note. If the aldehyde is formaldehyde, it will first oxidize it to formic acid, and this is the only acid in this world which is having CHO group. Only acid, carboxylic acid with CHO group. So it will further oxidize it to form carbon dioxide and water. Remember that this is going to be the final product in case of formaldehyde. Now ketones remains unaffected. Ketones are stable. H2O2 can't do anything. No effect. Stable. Gets. This is oxidative and reductive ozonolysis. Gets. Now I will take only 30 minutes, not more than 30 minutes to tell you alkynes, because most of the alkynes reactions already we have completed. Gets. How are you feeling now? Anything you want from Baba's side, do let me know. Anything, kids? Only 30 minutes more, kids, not more than that. Today, Baba has given only one break, kids. Only 30 minutes, kids. Only 30 minutes, not more than that, kids. Saucy is asking for questions. Okay, let me give you question first. Let me give you question first, then I will reach towards alkyne, okay? Okay, just try it out. I'm giving you 2 minutes. Then I will write down the answer of these questions. South Sea is playing games. South Sea knows very well the answers of these questions, but South Sea is writing like this, so everyone should get trapped. So let me write down the answers, kids. Let me write down the answers and just check it out. Rearrangement case. Major. No rearrangement. Markovnikov's. No rearrangement. Rearrangement may take place. So rearrangement case. No rearrangement case. Markovnikov's rule. Oxymercuration. M for mercury, M for Markov. Remember that. Anti-Markovnikov's no rearrangement. How many of you got the correct answers? Do let me know in the chat section that how many of you got correct answers, kids. How many of you got the correct answer, kids? Do let me know. Thank you, Sausi. Thank you. Wow, great, great. That's really great. Now, kids, let me give you one question, very good question. That's really awesome. That is known as very, very special question. Very, very special, right? We are to one equivalent. So the answer will be where it has been added. See, 1, 2, 3, 4. 1 and 4. That's why it is known as 1,4 addition product. Very, very important, kids. This is 80%, kids, and this is known as TCP. What do you mean by TCP? The full form of TCP is thermodynamically controlled product. The another one 1,2 addition, that is known as KCP. KCP full form is kinetically controlled product. Remember that if the same reaction would have taken place at minus 80 degrees Celsius, then 1,4 addition product will be minor 20%. The TCP one will be minor, 1,2 will be 80%. The KCP would have been major. Now kids, this is very, very important thing, that how it has been formed, how the reaction would have taken place. Now kids, let me explain the mechanism because it holds. This is very, very important, kids. I have to explain it, otherwise you will never come to know why this is happening. See kids, how the reaction is taking place. Kids, see. This is very, very important. CH2 double bond CH, CH double bond CH2, Br2 means Br positive, Br negative. The first Br, suppose it has attacked at this place. What you will get, kids? You will get compound like this, CH2 double bond CH, CH, CH2 Br. Bromonium ion. Now no rearrangement, but resonance will take place. No rearrangement can take place, that's okay. But resonance will take place. Now resonance is going to take place, kids. What will be the new structure? Just see. Now there are two carbocations. One is this carbocation, one is this carbocation. Which carbocation is more stable? Definitely that carbocation is more stable. And this carbocation is less stable. Now kids, another bromine will find very easiness to attack on which carbocation? The one which is more stable. So attack of bromide is more easy. Bromide attack is more easy, more comfortable on attack. Where to? There. The bromide attack from opposite side. The bromide attack is more easy, kids. Anti-attack. This is more easy. Easier attack, kids. because this carbocation is more stable. So attack is more easy, because suppose if I say this is the mosquito, well, mosquito will sit more at this place, easy attack. And this is less stable, so the bromide attack is tough. And anything which is tough, I can call it activation energy is higher. EA is higher. Low activation energy is required. Now, the attack is easy, that means attack is easy is KCP, kinetically controlled product. This is KCP. Easily attack. This is TCP, anything which is tough. But thermodynamics stays. What thermodynamics says? I love toughness. Those who are having energy, fire, they love to qualify the NEET exam. Others, they will they will join BSc. Less activation energy. If you are having more potential, then you will try to cross the higher energy barrier kits, right? So let's see what product they will form. The attack is easy. Here the attack is easy. This attack is easy, but the product, its product will be, attack is easy, but product, let's see the product. Its attack is easy, but product, let's see the product. Where the attack is easy, that product is not stable. Why not stable? Because it is having only one alpha hydrogen. Alkene is having only one alpha hydrogen. Not a stable product. Formed easily, but not stable. Although formed easily. Now this attack was tough. Attack was really tough, kids. Attack was tough, but product, product is stable. Why product is stable? Just see, this alkene is having 2 and 2, 4 alpha hydrogen atoms, so more stable alkene. So it will require more activation energy, and higher temperature is good for this. So let me tell you the each and everything in the form of graphical representation, so that you can understand in a better way, kids. If I say the reaction has started from here, cross this energy barrier. Now another energy barrier is like this, and this is giving to this path. Another energy barrier is like this. Now kids, see, till now, till this point, the carbocation is same carbocation is required, Z, let us say what is Z carbocation. Let me tell you, let me define what is Z carbocation. There were two carbocations formed, just see. We have got two carbocations, one this carbocation, one this carbocation. In between these two, there will be Z carbocation which is in between these two, like this, CH2 delta positive, CH delta positive, CH2Br. It's like this. So this is the carbocation which is common carbocation, just see, Z. So this is the common carbocation, but see after this, if I talk about 1,4 addition product, this is 1,4 more stable, that is TCP. This is 1,2 less stable, that is KCP. Now we have started from here, 1 butadiene, CH2 double bond CH, CH double bond CH2. This is the common carbocation, Z carbocation, and this is requiring less activation energy, but product is KCP, and this requires high activation energy. So to qualify this activation energy, temperature is required. If temperature is minus 80 degrees Celsius, then this will be major. If room temperature is there or high temperature is there, high temperature according to minus 80 degrees Celsius, 40 degrees Celsius is also high temperature. This will be the major. I hope that everyone got it. Just to let me know, kids, this is $1 million question, kids, $1 million question. Do let me know, kids. You got it or not? Everyone just do let me know. Now I will take 20 minutes only, kids, so that I can complete alkynes. Kids, everyone, are you getting it? Do let me know, kids. Everyone enjoying it? Just do let me know in the chat section. Do let me know, everyone. Just 20 minutes more, kids. Just 20 minutes more. Very good, very good. This one is clear to you, all of you not? Is this one clear to all of you not? Very good, kids, very good. Fantastic, fantastic. Now let me start alkynes. Just see, kids. If I write first preparation, I would like to say calcium carbide. Two plus, negative, negative, ionic bond, covalent bond. Add water to this, What you will get, kids? You will get acetylene plus calcium hydroxide. I hope this reaction is clear. This is known as calcium carbide. Calcium carbide, kids. Clear to all of you? Is this point clear to each and everyone? Calcium carbide. We got alkyne. Now, second alkyne, how to get? Just see. If I write down second preparation, CH2Br, CH2Br, if you see, dehydrohalogenation. Dehydrohalogenation. Now, if I react it with KOH alcoholic, heat, the K plus will come. K plus will come and form a bond with this Br negative and take away its electron. You will get plus charge at this place. And OH negative will come and take away this proton negative. You will get proton positive and get negative. Negative positive will form bond. CH2Br double bond CH2. Now remember that this lone pair will do resonance with this carbon, double bonded carbon. So this is vinylic bromide. Vinylic bromide means single bond is having partial double bond character. The single bond is having partial double bond character. Very strong bond. So this time you require even a stronger base, Na positive, NH2 negative. Now how this sodamide is stronger base? If I say kids, just see to it. If I compare that one is OH negative, one is NH2 negative, add H plus to both of them, they will become conjugate acid. This will become water, this will become ammonia. Now you know that its pK value is how much? 15.7 at room temperature. And this is having pK value of 35. Very weak acid, very weak acid. Very weak acids, conjugate bases, very strong base kits. This is given in NCERT kits. Reaction is given in NCERT. Now sodamide, what you are going to do kits? Next page. Let me tell you on next page. Once again kids, just see to it. CH2Br. Let me write down. Now what I have told you, K positive will come and take away this bromide along with the electron plus charge. OH negative will come at this place, take away this proton, negative charge, negative positive has formed the bond. Now sodamide will come. Na positive will take away this Br negative and ammonia's NH2 negative, conjugate base will take away this proton, negative positive, once again they will form a bond. Now if by chance if you have added more NaNH2, till now dehydrohalogenation had taken place, more NaNH2 if you have added, kids, NH2 negative will come like this, take away this proton, acid base neutralization, NH2 negative will come, take away this proton, NH2 negative. Now negative, sodium will stay at this place, positive, positive. Now examiner will ask, doing this, how many moles of NaNH2 will get consumed? You will get NaC triple bond C, Na disodium acetylide. Now by chance examiner, I've told you each and everything, if examiner has given you question like this, CH2Br, and you are using X moles of sodamide NaNH2, and you have got disodium acetylide, and he is asking about how many moles of NaNH2 got consumed. And this is the question. What's your answer, kids? Now what's your answer, kids? So definitely you have to give the answer that 4 moles, because it is starting no KOH is being used, no KOH is used. So answer will be 4 moles. If you are using KOH, then 3 moles, otherwise 4 moles. Now this point is very much clear to all of you. Till now it's clear. Just to let me know in the chat section. Everyone, is it clear? Everyone, is it clear, kids? Do let me know. Till now it's clear to all of you. Okay, now see, kids. Now let me tell you preparation of higher alkynes from lower alkynes. Preparation of higher alkynes from lower alkynes. In this, I would like to say 2 types of alkynes I am going to prepare, one symmetrical, one unsymmetrical. First, let me tell you symmetrical alkynes. Suppose I have got acetylene, I have reacted with excess of sodium, or at least 2 sodiums. Then I will get NaC triple bond C, Na. If I am reacting it with Rx, then what I will get, kids? If I am reacting it with let me write down properly, kids. Br CH2 whole 4 Br, and what do you think? What is going to happen? CH2 4, 1 CH2, 1 more CH2, 1 more CH2, 1 more CH2. This I will get, right? This is preparation of symmetrical alkyne. I hope that everyone, is it clear, kids? It's clear. Now see, unsymmetrical alkyne preparation. One equivalent monosodium acetylite now react it with once again sodium react with any type of alkyl halide So in this way we have prepared unsymmetrical alkyne kits. Till now is it clear? Now it will take 10 to 15 minutes only, kids. Now kids, really I appreciate your hard work, consistency. Kids, really I have become your fan. Now Baba has become your fan, kids. Now let me tell you, kids, reactions, chemical properties of alkynes. Now most of the chemical properties I have told you, only few are left, kids. Good morning, good morning, good morning, good morning. Good morning, kids. Aman Jha, thank you. Thank you, Aman Jha. Now see, kids, see to it, chemical properties. Let's see, kids. See, I am going to give you the trick, fantastic trick, right? First of all, let me tell you, if I am having alkene and I am having alkyne, who is more reactive? Definitely alkene will be more reactive. See first. Why, kids? if I react with electrophile, NO is there. So I will get CH2 positive, CH2E, and here I will get CH positive, CHE. Remember that positive charge is more stable on less electronegative atom. What I am saying, kids, where it is stable? Do let me know. Positive charge is more stable on? Do let me know, kids. Positive charge is more stable on? Tell me, kids. Positive charge is more stable on? See, it is sp2 hybridized, 2.75 electronegativity. It is sp hybridized, 3.25 electronegativity of carbon. So what I am saying, positive charge is more stable on less electronegative carbon. So this is more stable, so the reactivity order is like this. So why I want to say this, kids? Because alkynes are less reactive, and once alkynes are less reactive, kids, then if I react alkyne with water, it will not react easily. So what I am supposed to do, kids? I have to add 1% HgSO4, 40% H2SO4, kids. Now the water will add up. Now the water has been reacted, it has formed enol. Enol is least stable, kids. It will tautomerize. 1, 2, 3. Hydrogen will go there. And double bond will come at this place, kids. Now, kids, if you are doing this much in the examination, it is going to take too much time. It will consume too much time. How many of you want to do it immediately, kids? In the examination, it will take too much time. How many of you want to do it immediately, within fraction of seconds? Tell me in the chat section. Show me green hearts. If you want to do it immediately in the examination hall, show me green hearts in the chat section. I will tell you, kids, how to do it immediately in the examination. See, always remember that whenever mercury is there, kids, there is Markovnikov's rule. Mercury, M for mercury, M for Markov. Okay, Markovnikov's rule. Remember that? Will you keep it in your mind? Kids, tell me. Will you put it in your mind? Will you be able to apply it? M for mercury, M for Markov, M for mercury, M for Markov. Kids, do let me know first of all. Will you be able to remember it? M for mercury, M for Markov. Okay, now see. Any question it's coming, see. this carbon is having one hydrogen, this carbon without hydrogen. So Markovnikov's rule says give oxygen to this, give hydrogen to this. Both hydrogens will go that place. Oxygen will come at this place. You answer directly. No need of tautomerization, nothing else. Two hydrogens over here. One oxygen at this place. If you would have done without this trick, then how much time it is going to take? See, kids. Tautomerization, this is in all form. That is short trick. This is process which is easy. This is Baba HSP short trick. Which one is easier? Do let me know. Then I will tell you more short tricks. Do let me know how was it. Then I will let you know more short tricks, kids. Do let me know, kids. Wow, thank you, Parkavi. Okay, Aman Jha. Very good. Now, see, kids. Let me show you. Suppose you are provided with this compound. Now they have given question like this. Now either you can go with that process or directly you can do apply Baba's method. This carbon is not having any hydrogen. So Markovnikov's rule. And for mercury or for Markov, negative part of the region goes to that double bonded carbon or triple bond which is not having any hydrogen. So what you will get? Acetophenone is the answer. Now, on the other hand, if you apply brown hydroboration oxidation, anti-Markovnikov's rule. Now, see, kids, that also one more trick. HBO, brown hydroboration oxidation, 15 minutes more, kids. 10 to 15 minutes more. That's it. Now same question they have given you, suppose, see, like this. B2H6, water, THF, H2O2 OH negative. Now one thing is that you apply anti-Markovnikov addition. Then this is enol, then do the tautomerization. One, two, three. 1, 2, 3. This will go and this will come over here. This is the complete process. Okay. Now if you don't want to apply this mechanism and if you want to get answer immediately, then apply Baba HSP's rule, right? See. Let me do the comparative study so that everyone can understand. Both together, right? The same reactant I am going to take. It's once I will do Markovnikov's, once I will do anti-Markovnikov's rule, and let's see Baba HSP's trick. Now see kids, Markovnikov's rule, anti-Markovnikov's rule, that's it. Markov, anti-Markov. This is Markov, this is anti-Markov. Give oxygen to this, hydrogen to this, give hydrogen to this, oxygen to, that's it kids. See kids, got it? It's working or not? First of all, do let me know it's working or not kids. 7 to 8 minutes more kids. Just 7 to 8 minutes more. That's it. Do let me know kids, is it okay? Just 7 to 8 minutes more. It's working, very good. Very good kids. Okay, now see kids. Now let me tell you kids. Now one molecule has been added. Now where you will add second molecule? Just see, there are 2 points. If you are adding H plus at this position, what you will get? If you are adding H plus at this position, what you will get? Which carbocation do you think is more stable? Let us suppose this is X, this is Y. Now definitely it's those who are applying minus I, they will say X. Those who know about back bonding, they will say yes, this is more stable kids. Definitely this is more stable because stabilized by back bonding. Which back bonding kids? 2p pi, 3p pi back bonding. So this is more stable, this will not get formed, this will form, or that will minor, this will be major. So next chloride will attack on this only, kids. So the product will be CH3, CCl, Cl and CH3. Right, kids? You got it? Now by chance, if they have given you HOCl to add to show the reaction of HOCl, what you will do, kids? Just see. Same thing they will give you, and they will give reaction of HOCl. 2 moles of HOCl you are supposed to add. First, you will add Cl at this place. This is electrophile, remember that. This is nucleophile. In HCl, this is having negative charge, but in HOCl, hypoalous acid, this is having negative and this is having positive. Remember that. Now CH, Cl at this place and OH at this place, like this. Now kids, one more HOCl you are supposed to add. Now you have seen that Cl will go at this place because this carbocation will stabilize by back bonding. So OH will come to this place. Or you can see in this case Markovnikov addition. Directly you could have added Markovnikovs. You can apply once again the same rule as I have told you. What is supposed to get? You will get CH3, COH, COH, CHCl, Cl, and at one carbon, 2 which are not stable, so water will eliminate out. This OH and this H plus will eliminate out. Positive, negative will form a bond. CH3, CO, CH3. Last 2-3 reactions more, kids. Over and out after that. Okay. So till now, how it's going, kids? How it's going? Do let me know till now how it's going, kids. How it's going, kids, till now. Do let me know. How it's going, kids? Just last 5 minutes. Let me tell you the ozonolysis, kids. Let me tell you the ozonolysis, kids. Kids, those who are new, if anyone new, then hit the like button, kids. Smash the like button if you are new, anyone new. I don't think anyone new at this time, the morning time. Now see, kids, ozonolysis. Oh my God, what is this? Let me write down from my side only. First of all, reductive ozonolysis. Just like in the alkenes, do it over here. Now just remove 2 pi bonds, break 2 pi bonds. In alkenes case, we were in need of 2 bonds. So we have broken sigma and pi, but here just break 2 pi bonds. So we're out. Let's see how to just search for it. Just search for it, how to do. So check your answer. It's getting matched or not, kids, your answer. Now let's see oxidative ozonolysis. Oxidative ozonolysis. I hope this is clear. Your answer is matching. Now my dear friends, H2O2 cannot oxidize ketones, but H2O2 has got very special behavior that if diketone is there, means adjacent carbon ketones are there, it will break and it will convert into acid. And remember that note, if it would have been HCHO, then what it will do, kids, you know very well. It will convert into CO2 and water. It will convert it into CO2 and water, kids. Are you getting my point? Now see, kids. Now see to it. What I am going to give you, one note, very important note, kids, $1 million note. Like oxidative ozonolysis of alkenes and alkynes, we can obtain the same product with camenophore acidic medium or K2Cr2O7 acidic medium. Remember that, my dear friends. Just like oxidative ozonolysis, you will get product from this also, kids. Mark my words. Are you getting my point? Now, one more reaction, kids. Polymerization. If you take this acetylene and treat it with red hot copper tube, (500 to 600 degrees Celsius), you will get benzene. Remember this point, mark my words, very, very important, kids, very, very important. If you would have taken propine, you would have got acetylene. Now at the last, very, very important reaction, last but not the least, you know very well. Once again I am telling you, kids, this already I have told you so many times. Once again I am telling you, partial reduction. If you do complete reduction, you can carry out like this. H2, palladium, platinum, complete hydrogenation. This was complete hydrogenation. But if you carry out its partial reduction, which reaction? Hetu padosi cis Lindlar's catalyst cis alkene. Remember that. If you carry out nickel boride, known as P2 catalyst, or sodium liquid ammonia, known as Birch reduction, trans alkene. This is all, kids. Just to let me know any reaction. If you think it's left which you are never able to understand, I will let you know, kids. Otherwise, from my side, it's full and final, kids. Do let me know, kids. And really, your rank is for sure, because you are really hardworking, kids. And those who are hardworking, they will definitely get the best rank. Best rank. Kids. Now this is all from my side. I'm in front of screen just watching your comments. Really thank you, kids, for this much of patience. This much of consistency, this much of hard work really gets thank you, Sahana, Alia, Hero Brian, Srinath, Namita Madhu, Pon, Fam, Niranjani Pillai, Arya, Madhumita. Wow, Madhumita. Good. Wow, Wits. Thank you, Balaji, Sarha, Manja. Good night. Kishore Mani. Wow, Kishore Mani. Mamta, Jitu, Balaji, Yarya, Sausi. Yeah, definitely I will eat. Vishalni, thank you. Pritam Kumar Singh, thank you. Namita, Madhumita, Roman Rings, KSP. Yeah, definitely Sausi I will eat, really. Balaji Parkabi, Jitu, Hero Brian, Bot Shot. Wow. Niranjan Pillai, thank you. Take care. Vids, Saraha. Good night, Regina. Kishore Mani, good night. Jitu, good night. Namita Madhu, good night. Sahana, Baba, no words to explain your efforts taking bath. Thank you, Sahana. Really, thank you. I love you, kids. Love you. Wow, Sahana, you never forget anything. Great. Kishore Mani, Madhumita, thank you. Yarya, health is the first, yes. Yeah, definitely I will do dinner. Mahalakshmi, thank you. Sanjana, good night. Parkavi. Wow, KSP, really thanks.